irrigation system. Well, I have divided my presentation into 5 topics. One is irrigation scheduling. So, whenever we deal with irrigation water management, we must know irrigation scheduling. But as this is not the topic of today's training lecture, I will be very brief about that. Then, different irrigation methods. Though the topic of today's training lecture is micro irrigation systems, but still I would like to tell you, make aware you about certain principles of surface and sprinkler irrigation methods as well, because this will help us to compare surface and sprinkler irrigation methods properly with the micro irrigation methods. This will be followed by micro irrigation methods themselves. What are their topics? What are their types? What are their concepts, advantages and disadvantages? This will be of course followed by the main part of this training lecture, that is components of drip irrigation system. These include drippers, pipe network, filtration and fertigation units and other components as well. This will be followed by the different versions of the micro irrigation systems, that is micro sprinkler, bubbler, subsurface drip and subsurface irrigation methods. So there are basically 5 divisions of my today's training presentation, and we shall start with briefly irrigation schedule. As I already narrated, as I already told you, irrigation scheduling is the important part of overall irrigation water management. And basically what is meant by irrigation scheduling is to give answer to 3 important questions. That is, how to irrigate, when to irrigate, how much to irrigate. Basically irrigation scheduling means deciding how to irrigate any crop, when to irrigate, that is the frequency of irrigations, and how much to irrigate, that is for every irrigation what is the amount of water that we should apply to the crop in the root zone, of course. Okay, so how to irrigate, when to irrigate, how much to irrigate constitute the irrigation scheduling. In this case, the important are all the 3 questions, but the first question is how is the way of application. Now basically there are 4 ways of applying irrigation water to the crop, to the field. These are surface irrigation methods, in which there are border ridges and furrows and check basins. Subsurface sprinkler irrigation method. There are mini sprinkler, conventional sprinkler, Raingun and central pivot. Then 4th is the micro irrigation methods, that is drip irrigation method, micro sprinkler irrigation method, bubbler irrigation method, subsurface drip irrigation method. And as all of us are aware that basically the training is on the micro irrigation system. Okay, so naturally we'll be emphasizing on micro irrigation method in how to irrigate topic actually. The second part of irrigation scheduling is when to irrigate. Though this is not the topic of our today's lecture actually, today's training lecture, but when to irrigate means it is the deciding of the interval between 2 applications, 2 irrigations, or frequency of irrigation or application. Okay, that is deciding basically when we have to apply water to the irrigation field. And third is how much, that is for every irrigation, for every application by the chosen method, how much water, how much depth of the water, how much volume of the water we should apply to the field, to the crop. Okay, so in short, irrigation scheduling is how to irrigate, that is irrigation methods, when to irrigate, that is the frequency of irrigation, and how much to irrigate, that is deciding or applying the volume of water or depth of water at every irrigation. So this is irrigation scheduling, and as I already told how to irrigate, there are four methods: surface, subsurface, sprinkler and micro irrigation. And of course we'll be emphasizing more on micro irrigation method, but at the same time we'll see the principle of surface irrigation method and sprinkler irrigation method in order to enable us to compare these methods to the micro irrigation methods and understand the pros and cons of the micro irrigation methods. As I already told, there are basically four irrigation methods. One is surface irrigation, subsurface irrigation, sprinkler irrigation and micro irrigation methods. And our topic is on micro irrigation method. But the first in the series is surface irrigation methods. And surface irrigation method is further divided into four topics: uncontrolled flooding, border irrigation method, check basin irrigation method and furrow irrigation method. So we will in fact consider all these four irrigation methods just to explain their principle in short. In case of surface irrigation method, the water is allowed to flow over the land surface, and as water flows over the land surface, some of the water will infiltrate into the soil. This water may be stored in the root zone or may percolate beyond the root zone. Okay? While some of the water is infiltrated into the soil, okay? And some of the water move ahead actually. Okay? So this is basically the principle of surface irrigation method. So for that matter, for any irrigation method, irrigation means basically diverting the stored water in some sources to the field, and when it comes to the field, then distributing this water into the field in such a way that we store the desired amount of water in the root zone of the crop. The root zone of the crop may be 60 centimeter, 100 centimeter or 150 centimeter. So depending on the root zone of the crop, okay, and depending on of course other characteristics as well, okay, the desired amount of the water need to be stored into the root zone. Okay. So this is what basically when we do irrigation we need to follow. And as I told you earlier as well, in surface irrigation method we practice this, we follow this by allowing the water to move over the land surface. When water moves over land surface, some of the water infiltrates into the soil, stored into the root zone. Some of the water may depercolate beyond the root zone, and some of the water move of course over the land surface. And while this water moves over the land surface, the water will also be stored in the root zone, okay, in the next piece of land actually. So this is surface irrigation method. But if we do this in an uncontrolled way, then we call this as the flooding. That is, when we allow water to move over the land surface, and when water moves, if there is no layout, if there is no guidance for the water to move over the land surface, then it will move in an uncontrolled way. It will move randomly and haphazardly. So as you see in front of your slide, so this is the uncontrolled application of water, and we call this as flooding. Basically we don't classify flooding as the irrigation method. It is just delivering water into the field actually. So it is moving in any direction. You see that there is a lot of ponding. So some portion of the land is wetted, some portion of the land is dry, okay, but still traditionally this method was practiced actually. On one side we say that this is not an irrigation method, but on another side we also classify this into the surface irrigation method. It is not irrigation method because there is no guidance to water, how to flow, how to get applied into the root zone. But at the same time, as water moves over the land surface, okay, so we also call this as the surface irrigation method. But anyway, so uncontrolled flooding is not to be adopted in any case, and this is not the accepted practice of irrigation. If you see the adjoining photograph, this is the border strip which is being irrigated. Then you come to the sketch below the photograph of the photograph of the border irrigation method. This is the check basin irrigation method. In check basin irrigation method, the land to be irrigated is divided into the number of basins. Okay, these basins may be of square size, rectangle size. In case of the orchard plantation, they are circular as well. And in this method, the water from the field channel is diverted into these basins, and the basin is and this diversion will continue till the basin is filled with the desired depth of the water actually. And when the water is ponded over the basin, then this water will further infiltrate into the soil root zone. The third method is the ridges and furrows. Amongst all the surface irrigation method, this method is considered to be the efficient method. If you see the last row of sketches and photographs in this slide, and if you see the middle sketch, this shows you the furrows and ridges. Now in this case, the entire piece of the land to be irrigated is divided into number of ridges and furrows of desired dimensions. In this case, dimensions means the width of the furrow, or this width of the furrow, and also the longitudinal length of the slope of the furrow and length of the furrow. Okay? Water is applied into the furrows, and the plants are raised on the ridges or at the side of the ridges. And while water moves in the furrows, this water will seep towards the what we call ridges, and also infiltrate into the soil root zone as shown in the figure. Then if you see the left hand side of the sketch and right hand side of the sketch, I have shown how the ridges and furrows is practiced. So basically this border, check basin and furrow irrigation method, these are the surface irrigation methods. The principle is water is moved over the land surface, and as water has to move over the land surface has to be given certain desired slope, so that water will move in a direction of the slope. As water moves, the water will also infiltrate into the soil, and as water further moves, the water will infiltrate into the root zone of the soil. But the basic disadvantage of this method is that when water reaches towards the tail end, and there we have to irrigate the entire root zone, water has to be infiltrated into the entire root zone. But what happens while satisfying the need towards the tail end of the border or maybe ridges and furrows, the water will depercolate beyond the root zone towards the head portion of the border or ridges and furrows, and these are the unavoidable losses in the surface irrigation method. But I will like to here have one comment. While adopting surface irrigation method, it has to be adopted principally, that is deciding the dimensions of the layouts, maybe its length, maybe its width, maybe its longitudinal slope, maybe its stream size, and applying water scientifically. So surface irrigation method can also give us the irrigation efficiency, not like sprinkler or drip irrigation method, but at least much more than the uncontrolled flooding. Next irrigation method is the sprinkler irrigation method. Basically there are four types: conventional sprinkler, mini sprinkler, rain gun, and central pivot. In all these methods, water is brought to the field to be irrigated through the network of pipe from the source of water, and when it comes to the field, then this water is sprinkled in the form of rainfall over the field through the specially designed nozzles. So while water is sprinkled in the form of rainfall over the field, this water or droplets will fall over the land surface, and this will further be infiltrated into the soil. So if we have the proper combination of the sprinkler nozzles, spacing between sprinklers, then spacing between laterals, then it is possible that we irrigate the root zone of the crop efficiently. And when water reaches to the field, the water is sprinkled in the form of rainfall, and this water will form over the land surface, over the canopy, and as water falls over the land surface, it will infiltrate and the irrigation is affected. As you see from here, there are certain characteristics associated with this sprinkler irrigation method as well. But as this is not the topic of today, I'm not going to cover those in detail. But just below the photographs, you can see the sprinkling pattern. Okay, because in case of sprinkler irrigation method, the pressure at the nozzle is very, very important. So you see this is the nozzle, the middle photograph is the nozzle, and if you see the photograph at the left hand side, water is brought up to the field, then with the help of nozzle it is sprinkled into the air actually. But when water is sprinkled into the air, then depending on the pressure, its sprinkling pattern is there. Okay, so in order to have the uniform application of the water, we need to have the overlapping between the sprinkler as well. So if there is a overlapping, if there is no overlapping, as you see from the left hand side of the figure, then the sprinkling pattern is from the desired depth to the zero depth. So in order to avoid that, as shown in the figure on the right, there is the overlapping pattern actually. So overlapping patterns enable us to have near uniform application of the water. But even if we have these things actually in the field, the temperature and at the same time wind velocity may distort the sprinkling pattern. So when we design the sprinkler irrigation system, we need to be careful. And another thing is in sprinkler irrigation system is that if I have say particular piece of land, say 1 hectare, I don't have the nozzles for 1 hectare area at the same time, because it will add to the system. So I divide or I decide the system, conventional sprinkler irrigation system, in such a way that I divide the 1 hectare plot into the number of pieces, and then I irrigate first piece of the land, and then I move the sprinkler set from this piece of the land to the next piece of the land or next portion of the land. We call this as the shift. So we design the sprinkler irrigation system in such a way that we procure the components only for certain portion of the field, and when that field is irrigated, we move those components to the other portion of the field. But this is of course called as the shift. But while we shift the sprinkler set from one portion of the field to the another portion of the field, there are several difficulties as well. But in conventional sprinkler irrigation method, we do that. But in case the farmers don't want to shift the sprinkler set, because sprinkler set has to be shifted after irrigation is over, the field is wet, then we have to move in wet field, then dismantle the component of the sprinkler irrigation system, and then we have to move these components from the portion of the field which is being irrigated to the next portion of the field, and this causes a lot of difficulties. Okay, and in order to avoid these difficulties, the another version of the sprinkler irrigation system is there, which we call as the mini sprinkler. In case of the mini sprinkler irrigation method, it is possible that we procure the component that is the nozzles or the sprinkler irrigation system for the entire field actually, because If we do this for the conventional sprinkler, it becomes expensive. In case of mini sprinkler, the components of the mini sprinkler or mini sprinkler irrigation system is less expensive, and it is possible that we irrigate the entire field with the one set only. Okay, so mini sprinkler irrigation system is also becoming popular. Then there is another version of the sprinkler irrigation system. This is the rain gun actually. If we want to irrigate the large piece of land, say if I have 1 hectare field, and if I want to irrigate entire 1 hectare of the land with the help of just one nozzle, it is possible. Okay, with the help of rain gun actually. It is not possible with the help of conventional sprinkler or mini sprinkler. It is possible with the help of rain gun. In fact, the rain gun is very big size nozzle, as you see from the photograph here. Okay, its nozzle size is huge, 8 mm to 30 mm its nozzle size. It needs huge pressure to operate, up to 7 kg per centimeter square. Its radius throw is huge, up to 60 meter. Then of course if we have much larger field, then we need to have more than one rain gun, or if the same rain gun can be shifted to another place for next setting, and for that the spacing between two rain gun can vary up to 75 meter. We need huge discharge, you see, up to 25 liter per second. And the precipitation rate can vary from 30 to 60 mm per hour, and we can irrigate area up to 1 hectare. Okay, and as you see, we can even irrigate the crop like sugarcane with the help of rain gun. But of course, as pressure requirement is huge, discharge requirement is huge, and as we are trying to irrigate major portion of the land with the help of only one rain gun, then there are many difficulties associated in adoption of this rain gun. But nevertheless, if the farmer is having this much pressure, this much discharge, then farmer can adopt this irrigation method. And the last, in case of the sprinkler irrigation method, is the central pivot irrigation system. Now this irrigation system is practiced in USA, Australia, Brazil, some countries in Africa, but not in a country like India. Okay, so basically in this method, there is one long arm, as you see in the photograph on the top of this, and the sprinklers are mounted in such a way that they are facing towards the land surface. And in this case, this long arm moves in circle, and while this long arm moves in circle, the nozzles which are pointed towards the land surface, they will sprinkle water over the land surface or canopy, as you see in the the figure which is below this first figure. And you see the bottom figure at the right hand side, such kind of the circle is formed. These circles, they are the areas which are irrigated by the central pivot irrigation system. Okay, and with the help of this system, we can irrigate 100 hectares, 150 hectares, up to 200 hectares of the piece of the land in one go. So for that, when the land holding is very large, then and crop to be irrigated is same, then we can adopt this central pivot irrigation system. So in short, this is all about the sprinkler irrigation system. First system was conventional sprinkler. So this is normally adopted at the small farmer or marginal farmer level. The second is the mini sprinkler, third is the rain gun, and fourth is the central pivot. So all these four sprinkler irrigation systems have peculiar characteristics, and depending on the need, we can adapt those irrigation methods. Now let us move to the micro irrigation methods, which is basically the topic of today's main topic of today's training lecture. Just like surface irrigation method or sprinkler irrigation method, micro irrigation method is also divided into 4 irrigation methods. One is the surface drip irrigation method, micro sprinkler irrigation method, subsurface drip irrigation method, and bubbler irrigation method. So we'll see one by one these methods, and basically as our training topic is components actually. So we'll try to see the components of micro irrigation methods, and at the same time their advantages and disadvantages. But of course first we'll see the principle of the micro irrigation as the name itself indicates, micro irrigation method means we apply water in a small quantity, micro quantity, unlike in case of the surface irrigation method or sprinkler irrigation method. Basically, we define micro irrigation methods are the methods wherein the discharge requirement is up to 50 liters per hour. So this is say a very small or micro requirement of the discharge of the applicator or nozzle. And here we have defined the micro irrigation method as well. As you see on the slide which is displayed before you, micro irrigation is defined as the frequent application of small quantities of water directly above and below the soil surface to plant root zone, usually as discrete drops, continuous drops, or tiny streams through emitters placed along a water delivery line. These methods are being majorly used in agricultural practices for precise water application. So this definition indicates all the things actually. The first thing is that we apply water frequently, and as we apply water frequently, we have to apply water in small quantity. Okay, so we can apply water directly above the land surface or below the soil surface. Okay, and whenever we apply water above soil surface or below soil surface, the water has to reach to the root zone of the crop. So water is applied in the form of droplets. Okay, those can be discrete, droplet can be continuous, or those can be tiny streams as well. Okay, and this water in small quantity frequently is applied through the emitters, which are called as the drippers as well, and these emitters, they are placed along the water delivery lines, and we use these methods for the precision application of water. This is in short about the micro irrigation method. And concept of the micro irrigation method is also to apply small quantity of water frequently. So this is basically the concept of micro irrigation method. But what we have, why we have to do this? This is also important. Okay? For that, the concept, there is one concept that for the better growth of the plant, and at the same time for not to subject the plant to the water stress, we have to maintain the water content, moisture content in the root zone to the field capacity. So this might have been taught or covered in the previous lecture as well. Okay. Then okay, well, so we have to maintain water up to the field capacity. Then maybe we can do this with the help of surface irrigation, sprinkler irrigation method, or the different versions of surface and sprinkler irrigation method. Then why there is a need of this micro irrigation method? But that is not the case actually. Okay? In case of surface irrigation method, what we do actually, in case of surface irrigation method, we have to apply certain quantity of water to the field. We cannot apply small quantity of water to the field with the help of surface irrigation method, because in case of surface irrigation method, water has to move over the land surface, and when water has to move over the land surface, we have to apply minimum 5 to 6 centimeter of water at one time. Then only water can be moved over the land surface. If we try to apply some 2 mm, 3 mm of water per irrigation, then water won't move over the land surface. Okay. This is the characteristics of the surface irrigation method. So basically in surface irrigation method, we apply 50 to 60 millimeter of water in one irrigation. And if we consider normally 4 to 5 millimeter is the crop water requirement, then this water is sufficient almost for up to 10 days or up to 2 weeks. So in case of the surface irrigation method, thus if I apply water today, then I, I need to apply water after 2 weeks, because I cannot apply water tomorrow. Okay, so during the period of 2 weeks, what happened? So when as I am applying the large quantity of water today, the water for moisture content in the root zone for next 2 to 3 days will be near about saturation, which is also not the desirable condition. Then as the plant root takes water, then the moisture in the root zone will be depleted. But towards the end of the 2 weeks irrigation period, again the water content in the root zone will be dropped below the desirable level. We call this as the allowable depletion level. It will drop below the allowable level or desired level, and it may reach up to the wilting point as well. And if it reaches up to the wilting point, the plant will be subjected to the higher stress. So in case of surface irrigation method, so the variation in the moisture content in the root zone is right from saturation up to the near wilting point. And in this process, plant is subjected to the water stress either because of the higher moisture content level or lower moisture content level. But then if we and therefore in case of the surface irrigation method, it is not possible for us to maintain the desired level of the moisture content in the soil in order to have the proper growth of the plant. If we shift to the sprinkler irrigation method, basically in sprinkler irrigation method, it is possible actually to apply even 2 mm 4 mm of water in one application. Okay, but the frequency of the application will be once in a day and so on. And for that we have to design the sprinkler irrigation system in such a way that it will be expensive as well. Okay, and therefore though it is possible, but it is not feasible in case of the sprinkler irrigation system, because in case of the sprinkler irrigation system, on one side we apply water not in a micro amount, but in an amount which is much more than the micro amount. That is one thing. And then peculiar nature of the sprinkler irrigation system doesn't allow us to go for very frequent irrigation like in case of the micro irrigation method. But in case of micro irrigation method, what we can do is that we can apply exact amount of water. Say for example, today's my water requirement is 2.3 millimeter, and for that, say if I have to apply 473 milliliter of the water per nozzle or to the per plant, then it is possible by means of the drip irrigation method, by means of the micro irrigation method. So thus in case of the micro irrigation method, if I decide that I apply twice in a day, okay, or once in a day, we can calculate that amount of the water, and we can exactly apply that amount of the water to the roots. As you see in these photographs, you can see water is applied in the form of droplets, which are the discrete droplet. So these droplets are applied over the soil surface, and then whatever the water is being applied through these droplets, that will infiltrate into the root zone, as you see in the adjoining figure. Okay, so in this figure the moisture bulb is shown. Okay, so it is possible to apply water only into the root zone. It is by means of the micro irrigation method. Okay, so it is possible by means of the micro irrigation method just to irrigate the desired portion, okay, keep the unwanted portion dry, okay, and have the perfect control over the application of the water actually. Okay, so if today's my requirement is to apply 2 millimeter of the water, then I can apply 2 millimeter of the water with the help of micro irrigation method, but we cannot apply this water with the help of surface irrigation method or sprinkler irrigation method. So if I apply 2 mm of water today, then naturally I can apply another 2 mm of water the next day as per the requirement of the crop. Okay, so in this way I can apply water frequently in a desired amount precisely into the root zone. Okay, and therefore we can maintain the water content in the root zone near to the field capacity or in the desired range, as we can maintain all the time water content in the root zone at the desired level. Okay, of course the crop will not be subjected to water stress anytime during its plant growth. Okay, and plant will grow properly and we can achieve higher productivity. And at the same time, as we can have perfect control over the delivery of the water into the root zone, the water will not reach to the unwanted area, water will not percolate beyond the root zone. Okay, and so that there is no wastage of the water when we use the micro irrigation methods for applying irrigation. Okay, so before we shift to the next part, let us again summarize this. Okay, so basically micro irrigation methods are the methods where we can apply very small quantity of water frequently, but before that we should also know what is the importance of applying water frequently. So importance of applying water frequently is to maintain the soil moisture in the root zone within the allowable range. Allowable range means from depletion level to the field capacity, or not to allow the moisture content to drop below the allowable depletion level. This is not possible in case of the surface irrigation method, where we have to apply large quantity of water per irrigation, and when we move towards the end of the irrigation period, then the water content in the root zone will be less than the allowable depletion. Sometimes it can reach to the wilting point as well. It is neither possible, though feasible with the help of sprinkler irrigation method, but not possible. Okay, but in case of micro irrigation method, it is possible, and this is the beauty, or this is the main advantage of the micro irrigation method. I hope conceptually you have understood what we do in the micro irrigation method, and what is the basic principle of the micro irrigation method by which we can get the higher productivity with the application of the less amount of water. As we have seen in previous slide, micro irrigation method is applying water in a small quantity as per the need of the crop frequently directly into the root zone, either by applying over the soil surface or beneath the soil surface. Okay, and because of which I also told you that there is saving in application of the water and enhancement of the productivity as well. But besides that, there are several other advantages associated with the micro irrigation methods. Of course, as there are advantages, there are certain limitations as well. Okay, so we'll see these advantages and disadvantages. So I have listed most of the advantages and disadvantages in this slide. So basically there are three major advantages. One, as all of you know, saving in water application. In this case, why there is a saving, we have discussed already, as we can apply water precisely in a desired quantity directly into the root zone of the crop, and while we do this, we don't apply water in the unwanted area, that is the below the root zone, okay, or area which is not occupied by the root zone. Okay, and at the same time we bring water from the source up to the network, up to the field through the network of pipe, so there are no conveyance losses in case of the drip irrigation method. So normally what happens in case of surface irrigation method, we bring water from the water source up to the field through the network of the channels, or maybe through the network of the pipes as well. But when it comes to the field, in case of surface irrigation method, we have to distribute the water through the network of the field channels. Okay, and when water is distributed through the network of the field channels, there are distribution losses, and when it comes to the surface irrigation layout, that is border, check basin, or ridges and furrows, there are unavoidable application losses as well. But in case of drip irrigation method, we bring water from the water source directly up to the root zone through the network of pipes, so there are no conveyance losses, and at the same time, as we are applying water in a micro amount, tiny amount, precisely into the root zone of the crop, there are no application losses as well. Okay, so because we can get rid of application and distribution losses in case of micro irrigation method, there is lot of saving of water by micro irrigation method vis-a-vis the surface irrigation method. The experiments conducted worldwide have shown that if we adopt micro irrigation method compared to the surface irrigation method, there is a saving of 60 to 80% or sometimes more than that as well. Okay, and compared to sprinkler irrigation method, there is a saving of 25 to 50%. Okay, so this is the great saving actually. Even if we consider saving of 50% of water by micro irrigation method, then if I have water which can irrigate 1 hectare of the land, and instead of surface irrigation method, if we shift to the micro irrigation method, then it is possible for me to irrigate 2 hectares of the land, of course if I have the spare land available with me. Okay, so and you already know the benefits of the irrigated agriculture vis-a-vis the rain-fed agriculture. I repeat this again because this is important. As we can save water, and even if we consider 50% saving of the water, okay, and if I have water just equivalent to 1 hectare of the land and I am using surface irrigation method, then I can irrigate 2 hectare of the land if I shift to the drip irrigation method. This another 1 hectare otherwise would have been not irrigated. That was rain-fed or dryland agriculture, and we know the productivity of rain-fed or dryland agriculture. So instead of 1 hectare, I can irrigate 2 hectare of the land. So this is the strength of the micro irrigation method. Then saving in fertilizer actually. Fertilizer nutrients, they are to be applied for the better growth of the plant, for better productivity. Then there is a saving in fertilizer as well. So you may wonder why there is saving in fertilizer. Okay, because you know that when we apply the fertilizer, we have to apply fertilizer with water, because fertilizers, they get dissolve in water, and as water moves in the root zone, fertilizer will also move. But in case of surface irrigation method, the practice is different. Okay, so we cannot apply fertilizer with every drop of water, and whenever we apply fertilizer, and after application of the fertilizer we apply water, and as water is moved beyond the root zone in unwanted area as well, fertilizer will also reach to the unwanted area. The fertilizer will also move beyond the root zone, and whenever fertilizer or fertilizer and water move beyond the root zone, and if it is applied in an unwanted area, so that is wastage actually. So in case of surface irrigation method, there is wastage of the fertilizer. But in case of drip irrigation method, as we just saw in the previous slide, we can apply water perfectly into the root zone, and fertilizer we apply along with the water, and as water can be applied perfectly into the root zone, fertilizer can also be applied, or fertilizer is also applied perfectly into the root zone, and therefore along with water saving, there is fertilizer saving as well. The studies and experiments have shown that if we use drip irrigation method, there is the huge saving of fertilizer, that is up to 25%, and with 25% saving in fertilizer, farmer can save cost on his or her production practices as well. And third major advantage is increase in yield. Okay, this increase in yield, of course, is because it is possible in case of the drip irrigation method that we maintain the desired level of the moisture content in the root zone, which is not possible in other methods. And as we can maintain the moisture content in the root zone near to field capacity or in the desired range throughout the crop growth stage, and as we can apply water as per the required amount, there won't be any water stress to the crop. Okay, or the moisture content in the root zone will be at the desired level, and of course the plant will grow vigorously and will get the expected yield, which is much more than the yield that we get in surface irrigation method, or for that matter in sprinkler irrigation method as well. our studies have shown that by the adoption of micro irrigation method over surface irrigation method, there is increase in yield to the level of 25 to 30%. And if we compare this with the help of with the sprinkler irrigation method, then drip irrigation method can enhance the yield by 15 to 25%. So in nutshell, we can save water, we can save fertilizer, and at the same time, by saving these important resources, we can also enhance the yield. Okay, and of course, another peculiar advantage is that if I have the spare land, then with the help of the saved water, sorry, I can irrigate my spare land as well. Okay, and then there are other advantages as well, as I have shown here. You can read as well. Labor saving. Okay, in case of say surface irrigation method, as you see, when we apply water, then we need the human resources to divert the water from the water resources, bring it to the field, and when it comes to the field, then distribute this water into the field, and also apply this water into the surface irrigation layouts. A lot of labors are required actually, but in case of drip irrigation method, it is just what we call as opening the wall and closing the wall. In case of sprinkler as well, when we shift the one sprinkler set from one side to another side, there is much labor requirement as well. So we can save human resources or labor by adoption of the micro irrigation method vis-a-vis surface or sprinkler irrigation method. Then improved quality of produce. This is one important benefit of the micro irrigation method, which is largely ignored actually. Okay. Again, this is associated with the fact that we can maintain the moisture level in the root zone at the desired level, and at the same time we can apply the nutrients into the root zone of the crop, okay, at the desired level actually. Okay, it is possible with the help of as I was explaining that with the adoption of micro irrigation method, we can get the better quality of the produce compared to the surface irrigation method and sprinkler irrigation method. Of course, the reason lies in the fact that first is that we can apply water at the desired amount, and plant is not subjected to stress and it will grow vigorously, and at the same time we can also apply fertilizers and nutrient frequently with every drop of water as per the need of the crop, and which is of course not possible in other irrigation method. It is possible in micro irrigation method, and therefore we can get the improved quality of produce by means of the adoption of micro irrigation method. Then next is the efficient use of saline water. Okay, so all of us know that if we use saline water for irrigation, then if saline water is applied, then the salt will be accumulated in the root zone, as the salts are accumulated in the root zone, and if the tension increases in the root zone or moisture content decreases in the root zone, then with saline water, plant is subjected to extra stress, and plant roots, they cannot easily take the water from the root zone, and therefore plant growth is hampered actually. But in case of the drip irrigation system, as we can maintain the water at the low tension or at the high water content, and even if there is saline water, and if the salts are accumulated in the root zone up to the certain level, of course, then the roots won't find that difficulty in extracting that water, because water tension is low in the root zone, and therefore we can use the saline water efficiently as compared to other irrigation methods wherein the irrigation interval is large. Again, this is to deal with the frequent application of water, by which we can maintain the water content in the root zone at low tension or at the high content. The next is because of the adoption of the micro irrigation method, there is reduction in crop disease and pest. That is very much true, because in this case, first we don't apply water into the unwanted area, so there is no growth of the unwanted weeds and all those things, and crop disease and pest, they are minimized by adoption of the drip irrigation method. The next is early maturity, because we can maintain the fertilizer nutrient level, water level in the root zone as per the desired, as per the plant water needs. The early maturity and shortening of the plant growing season have also been observed by the adoption of the micro irrigation method, by which of course there is extra saving in water, extra saving in labor, and then we can also prepare the land for next season. Then weed control, as I already told while describing the reduction in crop disease and pest, as we can apply water exactly into the root zone of the crop, as we apply water exactly into the root zone of the crop, then the portion which needs to be dry, that is during the 2 plant rows, that is dry, and there is no application of the water in that portion, and therefore weeds will not grow actually. Okay, so as the water is applied exactly into the root zone of the crop, so that water will be available for the plant, and as we don't apply water beyond the root zone, and also in between the 2 strips of the plant rows are outside the root zone of the trees. Okay, of course naturally there is no question of growth of the weed in that area. Okay, the next is automation actually. This is one of the biggest advantage with the drip irrigation method. We can completely automate the drip irrigation system. It is possible. It is not that true about the surface irrigation method, and for sprinkler irrigation method it is partly true, but in case of the drip irrigation method we can apply the different degrees of the automation actually. So we can have the automation just for the operation of the valves for the application of the water, to the automation of the entire system, right from the fertigation, filtration, and other operations as well. Okay, so there is possibility of 100% automation in drip irrigation system, and many farmers, they are adopting those as well. I think later in the series of the training lecture there are two to three lectures on the automation, which is one of the biggest strength of the micro irrigation method. Energy saving. So nowadays, you know, the cost associated with the energy actually, as this method shows 50% of the water minimum, so you apply 50% less water, and that itself there is a saving in the energy actually, because we apply less amount of the water. At the same time, we apply water in very small quantity, so we don't need the high HP pumps. Okay, and because of these reasons there is saving in energy. This method is suitable to rolling topography. As you know that in case of the surface irrigation method, as water has to move over the land surface, land need to be leveled actually. If we don't level the land, water won't move along the layout of the surface irrigation method, or water will be ponded. In case of sprinkler irrigation method, of course this is also advantage associated with sprinkler irrigation method. In case of drip irrigation method as well, we, as this both the methods operate under pressure. Okay, so if the topography is rolling, and if the land is not, say for example, properly shaped, and if we design the system properly, then this method is suitable for the rolling topography as well. Next is we can apply this method for the marginal lands. Marginal lands can also be irrigated. So many times there are small lands in some corner and all those things, and applying water with the help of surface and sprinkler irrigation method is difficult. In case of drip irrigation method, even we can have one lateral, that's all. So it is possible to apply marginal water to the marginal lands by drip irrigation method. And of course, there is a lot of age in interculturing operation. When we adopt the drip irrigation method, we also modify the geometry of the plantation in such a way that various interculturing operations and the movement of the tractors and machinery can be done with the age. Okay, so these are the different advantages associated with the micro irrigation methods actually. Again, just to list out those: we can save water, we can save fertilizer, we can enhance the yield, we can save labor, we get the improved quality of produce, we can use saline water as well. There is less infection of the crop pest and diseases. We can shorten the crop growing season, then less weed, more chances of the automation, then we can save energy. Then this is suitable for the rolling topography without doing much land leveling, where we expose the soil as well. Then we can apply the small this method to the small piece of land. And also this method offers the ease in interculturing operation. Of course, with these so many advantages, there are certain limitations as well. Otherwise, this method would have been applied or adapted to the entire irrigated land all over the world. Okay, there are certain disadvantages and limitations associated with this method. Of course, the first is I have shown those in the red color text towards the right hand side actually. High initial investment. So when we apply water directly up to the root zone of the crop, when we apply fertilizer or nutrient directly up to the root zone of the crop, then we need certain infrastructure. And this infrastructure is having certain cost actually. In case of surface irrigation method, what we have to do, we have to just lift the water from the well with the help of pump and allow to spread over the land surface, or divert the water from the canal over the land surface. That's all. But in case of drip irrigation method, even if we lift the water through the pump, then there are certain components that are required to make possible water to reach to the root zone of the crop in the form of the droplets, and all these components need cost. So there is a high initial investment as well. But many governments all over the world, they are trying to provide the financial assistance to the farmer, those who adopt the micro irrigation method, especially in the water scarcity region. Then the second is associated with the technical know-how. In many countries, this method is new actually. Okay, but as this method of irrigation is new, but the irrigation is the age-old practice. So the farmers who are adopting surface irrigation method, they have the technical know-how. The knowledge is passed from one generation to another generation very easily for the adoption of the surface irrigation method. But in case of drip irrigation method, in many countries this is first or second generation, and there is no sufficient knowledge available for the design, operation and maintenance of micro irrigation system. And because of this technical know-how, many times there are problems associated with the adoption, operation and maintenance of the drip irrigation system. Of course, in many governments, they try to provide the training to the farmers and technical backup to the farmers for the adoption of this method. Then the third is maintenance actually. So naturally, as there are many components, those components need to be maintained. Okay, so the more care and maintenance is required for the adoption of the micro irrigation method. The most important is that when we apply water in small quantity, micro quantity, then this water has to be applied through the nozzles which are having small holes actually. If those holes are blocked, then there will be clogging and water won't be applied actually. So this is the biggest disadvantage associated with this method. But of course, there are components for this purpose, filtration. But if the filtration unit is not maintained properly, then there will be clogging. Then rodent problems, they are also noticed at many places if the system is not operated properly. And the next is the salt accumulation. When we apply water into the root zone in the form of the droplets, then what happens? This water displaces the salt in the root zone around the periphery, and many times we observe that the salt rings, they are formed around the drippers actually, and there is the problem of the salt accumulation as well, and at the same time we apply water in just required quantity, there may not be proper leaching of the salt as it happens in case of the surface irrigation method. Okay, so besides the several advantages, there are certain limitations associated with this method. High initial investment, of course this is on the procurement of the components required for this purpose. Technical know-how, as this method involves the operation of several components, then we need to have proper technical know-how, and at the same time this is first or second generation of the farmers who are using, so they need the technical backup as well. Maintenance problems, they are associated with the operation of the different components. Clogging is one such, and the rodent is another, and the salt accumulation around the periphery of the nozzle. So these are the problems associated, are the limitations associated with the adoption of the micro irrigation method. Nevertheless, there are solutions for this purpose as well, and some of the solutions we are going to see in this training lecture, but not in detail, because there are special training lectures for solving all these problems. Okay, and let us see why we need to adopt the drip irrigation system based on the benefits and the limitations that we have shown. Here I have tried to compare surface and drip irrigation method with the help of histograms on certain parameters. All these parameters I have shown on x-axis, that is water requirement, water saving, fertilizer requirement, fertilizer saving, yields, yield increase, additional area, and net benefits. And on y-axis I have shown the magnitude up to which the drip irrigation can offer these benefits. Okay, the histograms that will be shown are in two colors. One is in green color. Green color is for surface irrigation, and blue color is for the drip irrigation method. Okay, so let us first see the water requirement. So in case of surface irrigation method, if we need the 100 units of the water, then in case of the drip irrigation method we need only 50 units of the water. Thus drip irrigation method can save 50% of water minimum. Okay. Then regarding the fertilizer requirement, if surface irrigation methods need 100 unit of the fertilizer, then drip irrigation method will not need more than 75 units of the fertilizer. Thus there is saving of 25% at least by adoption of the drip irrigation method. In case of surface irrigation method, if we get 75 units of the yield, then by means of drip irrigation method we are able to get the 100 units of the yield. So naturally there is increase in yield up to the extent of minimum 25% in case of the drip irrigation method. And with the help of 50% of water that we saved, there is possibility of bringing another area of land or additional land of the equal amount by drip irrigation method. And with this additional land, if we irrigate that additional land, if by surface irrigation method, by not irrigating, if we are getting 50 units, then by means of drip irrigation method, by irrigating that we'll get the additional 50 units of the net benefits as well. So you see, so these estimates, they are much on the conservative basis, but nevertheless it gives us overall idea regarding the benefits of the drip irrigation method. Then again, regarding weeds, labor saving, automation, and quality, all these quantitative estimates, they are based on the averages, of course. If the weed infestation in drip surface irrigation is 100, then in drip it is only 50. Labor requirement, if in surface irrigation is 100, then in drip irrigation it is 50. So labor saving is 50%. Automation possibility in surface irrigation, it could be only up to 25%, but in drip it is up to 100%. Quality, in case of the surface irrigation method, if we are satisfied 50% with the quality, in case of drip irrigation we are satisfied with 100%. So less weed infestation, less labor, more automation and enhanced quality of the yield produced with the help of micro irrigation. But why in some region its adaptability is still poor actually? This is because of high initial cost, lack of technical know-how, training and support. If we need to invest 25 units on surface irrigation method for drip, we have to invest 100 units. Lack of technical knowledge. Surface irrigation method, as already told, it is the age-old practice and farmers know this as the knowledge is passed from one generation to another. But in case of drip irrigation method, this is first or second generation of the farmers and there is really lack of technical know-how. Then training requirement. In case of surface irrigation method, the farmers they are 100% trained, but in case of drip irrigation method, farmers they are less trained, and therefore there are needs of organizing such kind of the training program, not only for the practitioner level professional student, but also for the farmers to make them aware, to make them expert for the adoption of the drip irrigation method or micro irrigation method. Support actually, in case of maybe in surface irrigation method, there is 100% support is available within themselves, but in case of drip the support is still less, and therefore there is need for enhancement of the support at all the levels, and these are the reasons why in some region its adaptability is still poor. So what we have seen in detail the different advantages, benefits associated with the drip irrigation method, and at the same time its limitation as well, and we have to overcome these limitations. This is our main task as well, and for that such kind of the trainings are being practiced as well. So what we have seen till now, we have seen in short what is irrigation scheduling, briefly different irrigation methods other than micro irrigation method, that is surface irrigation and sprinkler irrigation methods. Then at the same time the concept and principle of micro irrigation method, and also the different advantages and disadvantages and limitations associated with the micro irrigation method. Now let us come to the different. Having seen the benefits, advantages, and at the same time limitation of the drip irrigation method, now it is important for us to know what are the different components of the drip irrigation method in order to achieve all these benefits. Okay, and also there are certain limitations and disadvantages of the drip irrigation method as well, and maybe we can overcome all those limitations and disadvantages, but for that we need to study the different components of the drip irrigation method. Let me tell you again that drip irrigation is one of the predominant method of the category of the micro irrigation system or micro irrigation method. There are other methods as well, say micro sprinkler, bubbler is there, and subsurface drip is also there. Okay, but the major difference between all the micro irrigation method is that the characteristics of the emitting device. Say for example, in case of the drip irrigation method, the emitting device is dripper emitter, so it emits or it emits the water in the form of the discrete droplets over the soil surface actually. In case of the subsurface drip, instead of applying the water in the form of discrete droplets over the soil surface, those are applied 10 to 15 centimeter beneath the soil surface. In case of the micro sprinkler irrigation method, instead of drippers, there are micro sprinkler, so which will in fact emit the water in the form of rainfall through the sprinkler like nozzle under tree or over the canopy as well. And in case of the bubbler, basically it applies the water in the form of large stream into the basin of the tree. So emitting devices, they are different, but irrespective of the emitting devices, the other components which are required for the micro irrigation system, they are same. as we are going to see drip irrigation method, and as the drip irrigation method is the major micro irrigation system, we shall study the components of this micro irrigation system in context of the drip irrigation system actually. Okay, but basically, as I have told you, barring the emitting devices, other components, they are almost same actually. Now this is the typical layout of the drip irrigation system. Many of you might have seen before. Some of the earlier expert lecture might have referred to this as well. Okay, and this particular sketch, particular diagram, in fact, shows all the parts of the drip irrigation system, all the components of the drip irrigation system, which needs to be studied, which needs to be looked into properly actually. Okay. Now when we start this, explaining this particular layout for the purpose of component, then we can start from the source of the water, or we can start from the end actually, that is from the field. But what I will do, I normally prefer to start from the field, go to the source, and again back from source to the field for the explanation purpose and also for the clarity actually. Now basically, as you see here, let us come to the field. Field means, you see, the plants are there in the field, which are in fact planted in rows, and you see the network of pipe along the rows of the plants as well. So this is basically field, and then this field is connected to the different devices, and the different devices is then connected to the water source actually. Okay, now again coming back to the field, you see there is one wall here, which is ball wall. Okay, and let us start from this ball wall, and ball wall is there on one particular pipeline, which is called as the submain pipeline. Okay, but besides that, let me tell you that there is one horizontal pipeline as well, which is coming from the different devices that we call as the control head. This pipeline is the main pipeline actually, and to this main pipeline, the submain pipeline is connected. As you see, it is coming into the field, and on both sides of the submain, there are again pipelines which runs along the rows of the plant, and these are known as the lateral pipeline. Okay, so basically this is the pipe network in the field. So main pipeline brings water to the submain, and submain brings water to the laterals. Okay, so laterals, they are spread over the soil surface, and in this figure, these are along the rows of the plants actually. So this means that one lateral is used for one row of the plant. Okay, so if we start again now from the end, so you see now lateral actually. Okay, lateral which is mounted or which is laid along the plant rows, all the laterals. Okay, on these laterals, if you see, there are drippers installed actually, or drippers inserted. You see the dripper slash emitter is written there. Okay, so there are the laterals in the field which are spread along the rows of the plants, and near each plant there are emitting devices which we call these as the drippers or emitters. Okay, in fact, what is done here in the process of irrigation, the dripper in fact emits the water in the form of droplets, discrete droplets in this case, over the soil surface. Okay, you see there is wet surface around the drippers actually. Okay, so as water is emitted from the dripper in the form of droplets, this water will enter into the root zone of the crop. Okay, and as a matter of this, the root zone will be wetted actually. Okay, so this is how the irrigation is done in drip irrigation system. Okay, and as you see, there is wetted area around each dripper. Okay, then these drippers, they are mounted on the lateral. Okay, these drippers, they are mounted on the lateral, or these drippers, they are inserted on the laterals at specified distance. Okay, so in this particular scenario, there is one dripper per plant actually, but this may not be the case. Okay, always. Okay, there may be 2 drippers per plant, or maybe in row crops the drippers, they are installed in such a way that the entire width of the row of the plant is wetted. The spacing between plant may be different, and spacing between the drippers of the lateral may be different, because it depends on the soil type, as we'll see later on. Okay. Then these drippers, they are mounted on the lateral. The water from the lateral comes into the dripper. Dripper has the arrangement in such a way that the water is emitted in the form of droplets, not in the form of streams. Actually, there is the arrangement in the emitter wherein the lateral pressure is dissipated completely in the emitter, and water emits in the form of the droplets. Okay, these emitters, they are mounted on the laterals. Now, if you see the laterals, they are on both the side of the submain. Okay, so it is not necessary all the time that laterals have to be on both the sides of the submain. Laterals could be on only one side of the submain, depending on the field geometry. Okay, and then at the head of the submain, if you see, there is one ball wall. Okay, at the head of the submain, there is one ball wall. Okay, see, this ball wall controls the flow of water into the submain, and eventually into the laterals and to the emitters as well. Okay, the area beneath the ball wall that constitute the submain, then the laterals on both the sides of the submain. Okay, this is known as one subunit actually. So one ball wall controls one subunit. Okay, so this subunit is now the area below the wall is known as the subunits, and there is submain on both sides of the submain. There are laterals, and on laterals there are emitters, and along the laterals there is row of the plant to be irrigated. Now in the field there may be several such subunits. Okay, just for the representative purpose in this figure, one subunit is shown. This subunit is, say, towards the right hand side, so there could be one subunit towards the left hand side, and there could be several such subunits, and each subunit has one ball wall at the head of its submain actually. Okay, so this ball wall will control the flow of water. Say for example, just for the purpose of our presentation, let us consider that there are 4 such subunits. Means there will be 4 such ball walls actually. Okay, and all these subunits, they will be connected to the main pipeline. Okay, all these subunits will be connected to the main pipeline. Water in fact will come from the main pipeline, and then from main pipeline water will go to the subunit. Okay, at any particular time it is quite possible that we have to only irrigate one subunit, so this ball wall will be open for that subunit, and for rest of the subunits ball wall will be closed actually. There could be the cases that there may be number of subunits, say maybe 10, and at that time it is quite possible that 2 subunits, they are irrigated together, so the 2 ball walls will be open, 8 will be closed, and after these 2 subunits are irrigated, these 2 ball walls will be closed and other 2 ball walls will be open. Okay, so there will be sequence of the irrigation, but basically purpose of the ball wall is to allow the flow of water into the subunit. Okay, then this submain of the subunit is connected to the main pipeline. As you see, this is the horizontal pipeline which is shown in this figure, and this main pipeline is further connected to the device which is called as the disc filter or screen filter. This is the primary filter. Okay, in between there are certain NRVs and all those things that I will explain at the end. Let me explain first the major components of the drip irrigation system. This main wall is connected to the screen filter, and then this screen filter is connected to another filter which is known as the sand filter. Okay, and this sand filter is connected to the fertigation unit, and this fertigation unit is connected to the hydrocyclone filter, and there is another one wall after hydrocyclone filter. This entire portion, that is from the first filter, or there is one NRV before first filter to another NRV, okay, after last filter, this is entire thing is known as the control head actually. So many a times when we discuss the micro irrigation system, the control head is often referred to. So this is the control unit actually. Okay, means all the submains all the subunits, they are connected to the main pipeline, and then this main pipeline is approaching towards the water source through the control head. So control head starts with one non-return valve, which is shown here. Then there are series of filters and fertigation units as well. Okay, so this is known as the control unit. So the water to the main comes from the series of the filters, okay, and also through the fertigation unit, okay, because this fertigation unit is required for applying fertilizer into the water, of course water soluble fertilizer. Okay, so we say that with every drop of water there should be fertilizer applied, and for that we need certain device, and those devices, they are known as the fertigation unit. Then fertigation unit is further connected to the hydrocyclone filter, and then hydrocyclone filter to another NRV, non-return valve. And if you approach towards the well, then there is one bypass valve and there is one pump as well. Okay, so pump lifts the water, and then whatever the excess water is there, that excess water is bypassed again to the water source, and required amount of the water is allowed into the main. Okay, so this is the layout, and these are the different components of drip irrigation system. Now if we and let us go now from the beginning. So I tried to describe you from the end. Now let us go from the beginning actually. For irrigating any field, or for that matter for the purpose of irrigation, you say involve any irrigation method, use any irrigation method, there needs to be a water source. Now in this case the water source is shown as well. This is the open dug well. Okay, the water source could be tube well, bore well, reservoir, pond, and all these pond, reservoir, tube well, bore well, or dug well, or open well as shown here. This water source may exist in the field or may be away from the field. Okay, so in this particular scenario, open dug well, that is water source, exists in the field. Water source could be river as well. Okay, so river outside the field. So that could also be water source. So water source could be river, then open dug well, tube well, bore well, ponds, and reservoir actually. Okay, but whatever the water source is there, we have to lift water from the water source, and then we have to push that water into the system at certain pressure actually, and for that we need pump is required for this purpose. So this is the this is regarding the water source. Now if the water source is not in the field, and if it is away from the field, then we have to bring water from or we have to pump water from the source which is away from the field into the field. In that case there may be one auxiliary pump as well. So depending on the distance between our field and also the water source. Okay, so when we bring water from the water source which is much away from our field, then when we bring that water to the field, then we need to have auxiliary storage and also the auxiliary pump, so that we will have the better control. Okay, so in this particular scenario, water source exists into the field. Okay, now as all of us know that drip irrigation system, this drip irrigation system operates on pressure, because for the operation of the nozzle itself and for bringing water from the water source up to the nozzle, that is dripper, we need certain pressure, and this amount of the pressure has to be built up by the pump. So this is the essential. Say for example, I intentionally describe you the last part first. The dripper, from dripper the water is emitted in the form of droplet. Okay, so for that there is pressure dissipation arrangement in the dripper actually, and for that we need certain pressure, and that pressure is 1 kg per centimeter square. So at the dripper we have to maintain normally the pressure of 1 kg per centimeter square or 10 meter actually. Okay, so that pressure is maintained there. So to have 10 meter pressure or 1 kg per centimeter square at the dripper, the pump has to develop more pressure, because we have to bring water from the pump through all these devices, through all these networks, okay, up to the dripper. So in this process there is a lot of frictional head loss, and to overcome this frictional head loss we have to have the extra pressure. Okay, so maybe pressure at the dripper is say 10 meter, and there could be the frictional head loss of the order of 20 meter in the system. So pump should be able to develop at least 3 kg per centimeter square or 30 meter of the pressure actually. This is just for the example. So we calculate this in the design procedure, which will be covered later on. Okay, so this is there. So pump should be able to produce the required pressure, okay, which is necessary, say 3 kg or 30 meter in this case. And at the same time, pump should be able to throw the required amount of water at the desired pressure. Say for example, so here is the subunit, and in this subunit, say there are 1000 drippers. Okay, so and if each dripper is having the discharge of 4 liter per hour, so this pump should be able to throw water at the rate of 1000 into 4, that is 4000 liters per hour, okay, at the head of 30 meter. So this should be the pump characteristics actually. Okay, so in this particular case, the pump is centrifugal pump. Pump could be submersible pump as well. Okay, so purpose of the water source is to supply the water. Purpose of the pump is to throw the water at the desired head for getting the desired discharge. Okay, so this is the purpose of the pump. Sometime what will happen that we may not need the entire discharge because because we design the system for the peak water requirement, and when in actual operation we may need less discharge. Okay, so it is quite possible, or at the same time we may have the different number of the emitters for the different subunits. Okay, so we may need the different discharge to operate the different subunits. So for that, if there is any excess what we call as the water, that water we need to bypass again into the water source, because we don't want to allow the excess water to enter into the system and not to cause any wastage of water. Okay, so for this purpose, what we do, we should have certain arrangement to bypass the excess water, and this arrangement is provided with the help of the bypass valve, which is shown here just near the pump. Okay, so pump lift the water from the water source at the desired pressure. Okay, and as we have to in fact allow only the required amount of the water into the system, bypass valve will bypass or divert the excess water again into the water source. Okay, and then this water will from the main pipeline, this water is going to the device which is called as sand separator or hydrocyclone filter. Okay, so water is being lifted from the water source, from the pump, then excess water is diverted back into the water source. Okay, and the desired amount of the water is being passed through the filter, which is called as the sand separator or hydrocyclone filter. Okay, now what is the purpose of this hydrocyclone filter? Why this filter is required? Basically, there are three filters which are shown in this diagram. The filters are required to filter the impurities in the water that exist, okay, and allow the impurity free water system to enter into the system. Okay, by chance, if the impure water enters into the system, then there is possibility, not possibility, there is 100% guarantee that the emitters or drippers will be clogged, because they are having very small apertures, and if the sand particle or clay particle or certain debris enter into the system, debris will of course block the pipe network as well, but these clay particles or sand particles will also block the emitters, and once the emitters they are blocked, it is very difficult to notice those emitters, and also there will be variation in the discharge, or there won't be any discharge, and lot of non-uniformity will be there, and in fact this non-uniformity will reach to such an extent that the uniformity in surface irrigation will be better than in the drip irrigation method if we don't look into these clogged filters. Okay, so for that clogged emitters actually. So for that the filters are required. So there are three filters which are shown. It is not necessary that all the time all the three filters are required. So as you see, there is one conical kind of the thing which is named as sand and separator or hydrocyclone filter. Ahead of this there is one cylindrical kind of thing which is known as media filter or sand filter, and then ahead of this towards the field there is one again inclined filter which is known as the primary filter. It is either screen filter or disc filter, out of which this primary filter, that is screen filter or disc filter, is required even if we use the distilled water for the purpose of irrigation, because we are using this system in the field, and in the field there are all the chances that you take any care, there are chances that the clay particles or sand particles will enter into the system. So there is necessity of primary filter, which is screen filter or sand filter. That is must actually. Okay, let us again come back to the first filter, sand separator. Now this sand separator or hydrocyclone filter is particularly required if there is a lot of sand load into the water. Okay, because we don't want to enter the water with sand into the system. Okay, so whenever there is a lot of sand load into the system, then we have to separate this, and for the sand separator is used. Normally when the source of water is tube well or river, then there is possibility of having sand load in the water, and to separate the sand load from the water and to allow sand free water into the system, the sand separators are used. If you are confident that in a system or water resources they don't have sand, then there is not necessity of the sand separator or hydrocyclone. So this means that it is optional and it depends on the source of water or impurities in the water you are using. Then this sand separator in fact is water from the hydrocyclone filter, then it is going to the sand filter, and before the sand filter there is venturi actually, means there is a fertigation device. Okay, so the purpose of the fertigation device, now there are different kinds of the fertigation devices which we'll see later in this lecture itself actually, as far the types are concerned. Okay, so venturi is one such fertilizer applicator. Its purpose is that to apply the water soluble fertilizer into the system. Basically broad purpose of the venturi is to allow water soluble fertilizer from the tank into the system, so that this water soluble fertilizer will be dissolved in water, and water along with the fertilizer will enter into the filter which is shown here. This is known as the sand filter. Now what is the purpose of sand filter? Okay, basically sand filter is used to separate any organic material, algae or debris, or say leaves and all other things which exist in the water from water actually. Okay, because hydrocyclone filter cannot do this. As its name indicates, hydrocyclone filter operates on the principle of centrifugal force actually. So in this case the heavier particles, that is sand, they are separated from water, but the lighter organic material they cannot be. Okay, and therefore to separate the lighter organic material such as algae and all those things, we have to use the sand filter, or this is known as the media filter. Okay, so when we have to use media filter, when normally when we use the water from the open well or reservoir or pond, there is possibility that there is debris, because this could be covered by having the trees and all those things nearby. So there will be debris, leaves, and as they are exposed to the sunlight, there are chances that the algae are developed there. Okay, and so whenever we have the water from these sources, and whenever there is a possibility of such organic matter in the sources, then we have to use the sand filter. Normally for the smaller fields, if we are pretty sure that there are no organic matters, we don't use the sand filter. Okay, but when the field is quite large, of the order of 5 hectares or more, then normally we prefer to use the sand filter. And from the sand filter, water with the fertilizer will come into the primary filter. I told that this is essential. Water is the quality of the water. Okay, so by chance if there are any clay particles and all those things, primary filter will separate the clay particles from water, and thus the entire what we call as the impurity free water, but along with the fertilizer, will now enter into the main pipeline, and from main pipeline it will enter into the subunit. Okay, so again we repeat up this portion. From water source, water will be pumped at the desired pressure and also in the desired quantity, and if the by the pump, centrifugal or submersible pump. If by chance if the quantity is more, we have to bypass this quantity with the help of bypass valve. Then if the water source is what we call river or tube well, and if there is sand load, then we have to use the sand separator. Then we have to apply fertilizer with every drop of water, so there should be any fertigation device, Venturi's such device which is installed here. After that there is sand filter which we have to use to separate or filter out any debris or algae or any organic material from the water. And then water comes into the primary filter, and by chance if there are any clay particles or soil particles into the water, so those will be separated by this primary filter, which is of screen filter type or disc filter type. Okay, again one thing is that this primary filter is must, but sand filter or hydrocyclone filter, they are to be used depending on the impurities in the water and depending on the water source. Okay, from now this water has entered into the main pipeline, and from main pipeline this water is trying to enter into the subunit. Okay, so if valve at the head of the submain of the subunit is on, then this water will enter into the subunit. Basically this water will enter into the submain line, and from submain line this water will enter into the lateral line. Okay, on both the sides or on one side. And as the emitters, they are mounted on the lateral, then water will enter into the emitter. And as I told you that in the emitter there are pressure dissipating devices, and because of which the water which is at the pressure of 1 kg, that will be converted into the zero pressure, and water will emit in the form of the droplets onto the soil surface. And once it drops, once water falls onto the soil surface, it will infiltrate into the root zone of the crop. So in this way the irrigation is effected. So as you see here, from water source up to the root zone, okay, so water is communicated through the network of pipe, and virtually there is no conveyance losses here. But when water comes to the dripper, then the water will fall onto the soil surface, and that will directly enter into the root zone. So in this case we are applying water from water source directly into the root zone. So as you see, pump, different kinds of the filters, fertigation unit, pipe network and emitters, these are the important components of the drip irrigation system. Okay, and there are now certain valves shown here. Okay, one valve is, say if we start from the beginning, there are two non-return valves. Okay, one non-return valve is just after the pump, and another non-return valve is just after the control unit. Okay, so basically in between two non-return valve there is control unit. Okay, so the purpose of the non-return valve is that if by chance if we stop the pump, or we have to stop the pump anyway, if the pump stops, and basically if the pump stops suddenly, then there are chances that the water in the system will flow back to the pump. Okay, and if this entire water load flow back up to the pump, and then this water will fall over the impeller of the pump at great pressure, and the pump impeller will damage. So in order to protect the pump, basically pump impeller from the returning water in case of the pump is stopped, okay, non-return valve is necessary. So this is the purpose of first non-return valve. And then after the control unit there is another non-return valve. This may not be necessary, but what this non-return valve does actually, if there is water in the subunits, and if pump stops, then again this water will flow back, and this water may damage our filters and fertigation unit, or at the same time there are other valves and pressure gauges, so they may be damaged. In order to protect the entire control unit and all the components of the control unit, non-return valve is also provided just after the control unit. Okay, so this is about the non-return valve. We have already seen the bypass valve. We have seen the ball valves which control the flow of water into the subunit, and there is one more valve which is the air valve actually, which is shown at the end of the main line. Okay, so and this is normally provided at the highest point in the field. Okay, there is possibility that air may be entrapped into the system, and we have to remove that entrapped air. Otherwise, there will be water hammering, and the components of the drip irrigation system will be damaged. And for that, air wall is to be installed, and this is at the highest point in the field. And then if you see towards at the end of submain there is one flush wall, and also at the end of lateral there is also flush wall, and there are end stops. So first let us see the purpose of flush wall. Okay, now this flush wall is because this submain is not totally closed, actually there is a wall, flush wall. So flush wall is to be opened to clean the pipe network. Say for example, though there is filtration system and all those things, but over a period of time, if certain impurities they entered by chance, and if those impurities they lie in the system, in the pipeline, then there will be obstructions to the flow, and those have to be removed. So for that case, what we do, so when we don't want to give irrigation, then we open the flush wall and we start the water for about 5 to 10 minutes. Okay, so that whatever the impurities or debris they exist in the pipe network, okay, those will be removed. Okay, as we have opened the flush wall, and after that process the flush wall can be closed. In the similar way, there is lateral flush wall as well. So many times the lateral flush wall they are not necessary, but we can install that. A lateral flush wall they are installed at the end of the lateral. The purpose is again same. So we have to make this flush wall open on, and allow water for some time into the system, so that all the impurities will be removed. If there are no flush walls, then there are end stops actually towards the lateral. Means these laterals they need to be closed at the end, otherwise the water will flow out of the lateral and away into the field. So there are the end stop. Okay, so in this way, as you see, we have seen the important component of the system, that is drivers or emitters, then pipe networks in the form of laterals, submain, main, then control unit that consists of the filter units, either hydrocyclone filter, sand filter, and primary filter in the form of screen or disc filter. Then there is fertigation unit. Then there are number of valves: non-return valve, ball valve, air valve, flush valve, okay, bypass valve, and there is a pump to lift the water at the desired pressure and at the desired discharge, and water source for the water. Okay, and besides that there are the pressure gauges as well, because this system operates under pressure, and we have to monitor the pressure. For monitoring the pressure, we have to measure the pressure. For measuring the pressure, especially across the filter, there is necessity of the pressure gauge. Okay, so if there are there are pressure gauges across the filter, it also shows us that it is if the pressure drop across the filter is beyond the desired limit, it shows us that no, this is the time that the filter should be maintained, filter should be cleaned. Okay, and it also shows us what is the pressure at the different points, and if the pressure is less than the desired one, then we have to make the corrective measures so that the pressure is the desired pressure. Okay, so this is all about the components of the drip irrigation system, and as I told you already that more or less these are the components of other micro irrigation system as well. Thus, I have listed these components of the drip irrigation system again, because we are going to see important components one by one. Of course, first is the dripper or emitter. Then this is the important component, pipe networks in the form of laterals, submains, and main. That also we saw. Control head in the form of filter unit, fertigation unit, pressure gauges, bypass assembly, and pump. Different kinds of the valves: flush valves, non-return valves, ball valves, air valve, bypass valve, and automation unit. It is of course optional. If you can have the part automation of the drip irrigation system, full automation. So this part of course will be covered later on as well. And besides this, I have shown also another representative figure of the drip irrigation layout showing all these components, right from the dripper or emitter, pipe network, control head, valves, and automation unit. Now let us see the important component, dripper of the system. It is the most important component because it governs the uniformity in application of the water. In market there are several kinds of the dripper, so we can categorize those drippers based on the different characteristics. Okay, but here I have used 5 most important characteristics. One is online and inline emitters, based on how the emitters they are mounted on the lateral or inside the lateral. The next category is pressure compensating and non-pressure compensating emitters, that is PC emitters and NPC emitters. This is another category. Third category is whether it is nozzle type, that is point source, or perforation type or line source. Then fourth category is whether emitter or dripper is single exit or multi-exit. And the fifth category is whether it is of the vortex types or linear type or the labyrinth type. Okay, so these are the 5 categories, and I will try to explain all these categories one by one, and I will also tell you what kind of the filter, what kind of the drippers to be used. This is just a mix of the different kinds of the emitters or drippers. So there are online emitters, inline emitters, then vortex kinds of the emitters they are there, labyrinth kind of the emitters are there, but all they are the single exits. There are some PC kind, there are some NPC kind. But let's come to the first category, that is the drippers, online or inline. Okay, so as you see here, the drippers they are mounted on the lateral, and therefore these are known as the online emitters actually. So these are mounted on the laterals. Okay, so that's why these are the online emitters. And when the emitters are integrated inside the lateral, then we call these as the inline emitters actually. So I will show the picture of inline emitter later on. In case of the online emitter, as you see, there are the laterals, and on laterals the emitters they are mounted actually. So in fact emitter comes separately and lateral comes separately. Okay, and we have to procure laterals emitters, and then we have to mount the emitters on the laterals by making hole into that. Okay, so this is the online emitter. Then this is also one another category of the online filter. Okay, online emitter actually. Then inline emitter. Okay, so these are known as the inline emitter, or sometime it is also known as the integrated emitter. As you see in the previous slide, we have seen that the emitters were mounted on the laterals, but here you see that emitters they are inside the laterals actually. Okay, and this mounting of the emitters inside the lateral is done in the manufacturing process. This is not like that. For the online emitters, we have laterals, and then we have option to have the different kinds of the online emitters, and then we can install ourselves these online emitters on the lateral. But in case of the inline emitters, mostly those are of the labyrinth or linear type. As you see here, those are inserted or integrated inside the lateral in the manufacturing process itself, and therefore they are known as the inline emitters. And it is not like that we have to procure inline emitters separately and push those inline emitters into the lateral. We cannot do that. So inline emitter lateral comes separately, that is lateral comes with the inline emitter. Okay, now the question is that when to use the online emitter and inline emitter, because in market, so online emitters they are also available, inline emitters they are also available. First let me tell you that these inline emitters normally, or inline drip lateral line is normally to be used when we don't move the laterals actually, because whenever we have to move the laterals in the field, now when we have to move the laterals into the field, say for example if we take the seasonal what we call as the crops such as vegetables, flowers, and in this case we say irrigate the crop in one season, and then in next season we may take another crop. So for that, after first season is over, then we have to collect the lateral in the field, and then we have to store those laterals somewhere, prepare the field for another crop, and then again bring those laterals to the field and again lay those. Okay, so in that case lot of movement is there. Then another case is the crop like sugar cane, say for example. So during the earthing up operation, we have to move the lateral from one place to another place. So whenever there is a movement, we have to use the inline kind of the emitter. Of course, the reason is that when we move the lateral, there are chances that if we use the online kind of the emitters, say they will be dropped or they will be removed from the lateral, and in the field if those kind of the emitters they are removed, then it is really very difficult to locate those kind of the emitters in the field. So if we use the inline kind of the emitters as they are integrated into the lateral itself, so even if we move the laterals from one place to another, there are no chances of removing or getting the inline emitters dropped from the lateral into the field. Okay, so whenever we have to move the laterals here and there, then it is better to use the inline emitters. Okay, then when to use the online emitters? Okay, online emitters are to be normally used when we don't have to move the laterals, and when we don't have to move the laterals, it is generally for the orchard plantations. Orchard plantation is having the life of more than 10 years, 20 years and all those things. But anyway, the life of the these laterals and the drippers is not more than 7 years. Okay, so for the orchard plantation, we can lay the laterals, okay, along with the online emitters, and then we don't have to remove those actually. Okay, and for that purpose, we can use the online kind of the emitters when we use the system for orchard plantation. Okay, so this also doesn't mean that for orchard we shouldn't use the inline kind of the emitters. We can use the inline kind of the emitters, but those are a bit expensive compared to the online emitters. And online emitters also one advantage as well. Okay, this advantage is that say for example for the orchard plantation where the laterals and drippers they are located sparsely, and if we just take a round in the orchard plantation, we can see the individual drippers as well. And if we find that if some emitter is not giving proper discharge, then it must or if it is clogged or if it is blocked, so this means that we have to remove that, we have to clean that, or we have to replace that. Okay, so this we can do very easily for the online emitters, but for inline emitter it is very difficult to locate the emitter which is clogged unless the area near that emitter is dry or the plants are wilted. Okay, and even if it is located, then it is difficult to remove actually, and it is difficult to clean. In case of the online emitters, if we find that if certain emitter is clogged, not giving proper discharge, so we can remove, we can clean either with the help of acid, chlorine, and then if it is giving proper discharge, we can again install that emitters on the lateral. If not, then we can have the new emitters and we can install that. It can be easily done for the online emitter, but for the inline emitter, of course there are limitations for doing this. Those limitations are that in case of the inline emitter, even if we locate that, we have to cut the lateral, remove the online emitter, then we have to have joiner, another emitter, and with the help of joiner we have to connect the emitter into the inline emitter. So the process is a bit cumbersome, though it is possible, the process is cumbersome. Okay, so the inline emitters we generally don't prefer to be used where it is not required, that is the orchard plantation. And inline emitters we generally advocate to use where there is movement of the laterals, such as the seasonal crop and the crop like sugarcane. Okay, so this is all about online emitters. We have just now seen the inline emitters and online emitters. Now there are NPC, that is non-pressure compensating emitter, and pressure compensating emitter. So what is the purpose of this? But before that, let us see that there is a relationship between pressure and discharge. Okay, so if pressure in the system is more, the discharge is more. If the pressure in the system is less, discharge is less. Similar thing happens for the dripper as well. If the pressure at the emitter or dripper is more, the discharge from the emitter will be more, and if pressure at the emitter is less, the discharge is less. So when this happens actually, okay, so this happens along the lateral. Okay, so if we take any lateral, at the head of the lateral there will be more pressure, and if we go towards the tail of the lateral, then as water, when it reaches to the tail of the lateral, it has to overcome the head loss due to friction which is offered by the inner surface of the lateral. Then to overcome that head loss due to friction, certain pressure in the system will be utilized, and therefore as we go further towards the end of the lateral, the pressure will be reduced. So in short, in the beginning the pressure is less at the lateral, and at the end the pressure is in the beginning pressure is more, and at the end the pressure is less. So this means that if we install the dripper and if we measure the discharge of the dripper at the head, it will be more, and the discharge at the tail will be less. If we give example, say for example, normally the pressure is to be maintained at 10 kg, 1 kg or 10 meter. Okay, so if we maintain the pressure of 1 kg at the head or 10 meter, then we may get the rated discharge of 4 liter per hour. But if we go towards the tail, then if the dripper, if the pressure is reduced, say to 6 meter or 0.6 kg per centimeter square, then instead of 4 liter per hour, we may get the 2 liter per hour. Okay, so this is the characteristics of the non-pressure compensating type of the emitter. That is, if the discharge varies, if the pressure varies, discharge also vary. Okay, so this is the characteristics of the non-pressure compensating emitter, and normally in the market the emitters available, they are non-pressure compensating or NPC kind of the emitters, or all kinds of the emitters they are NPC unless we refer this specially as the pressure compensating emitters. And in case of pressure compensating emitter, what happens, special kind of the arrangement is made into the emitter such that if over a certain range of the pressure, if there is variation, the discharge is same. Okay, so for example, if we take the previous case, if there is variation of the pressure of 10 meter to 6 meter in the system, okay, then there is arrangement made into the dripper such that over that variation of the pressure you will get the same discharge, that is 4 liter per hour. Okay, so when we use the NPC kind of the emitters for this particular case, that is variation of the pressure from 10 meter to 6 meter, then the variation in the discharge was from 4 liter per hour to 2 liter per hour. Okay, so this means that our emission uniformity was just 50%, which is not at all desirable even in case of the surface irrigation method. But instead of that, if we use the pressure compensating emitters, then we'll get the same discharge everywhere, but we have to use the PC kind of the drippers. Of course, these are expensive compared to the non-pressure kind of the NPC kind of the emitters. This I will also try to explain with the help of the layout of the drip irrigation system in the next slide. Properly for its diameter and length. So for example, I will take just one example because this will be covered in the design class, or this might have already been covered as well. If you take any lateral actually, so let us take the last lateral here. So there is this emitter and there is another emitter at the end actually. Okay, so pressure available here is more, pressure available here is less, because when water moves inside this lateral, okay, so this inner side of the lateral will offer resistance to the movement of the water, and to overcome that resistance certain pressure will be required, and that pressure will be taken from the available pressure. Say for example, here the pressure is 10 meter or 1 kg per centimeter square. When water moves ahead and when water comes here, some of the pressure out of the 10 meter or 1 kg pressure will be required to overcome the frictional head loss as water moves from head to tail. So if here pressure is 10 meter, here pressure may be 6 meter. Okay, so therefore here if you get the discharge of 4 liter per hour, then here you may get the discharge of 2 liter per hour only. Okay, and if you get the discharge of 4 liter per hour at one place and 2 liter per hour at the end, then its uniformity efficiency is just 50%, and we don't want the drip irrigation system to operate at the 50% efficiency. In fact, it is considered that the efficiency of drip irrigation system has to be 90 or 95%. Okay, so then in order to avoid that, we have to keep the pressure difference between first dripper and the last dripper such that we get the 90 to 95% of the pressure, 90 to 95% of the emission uniformity. Okay, so this will be covered in your design class. But my intention of telling is that for that we have to limit the length of the lateral. So maybe for this we may have to keep the length of the lateral as only 50 meter. Okay, if we keep length of the lateral as 100 meter, then first emitter gives 4 liter per hour discharge, last may give 2 liter per hour discharge. 50% is not advisable, so you have to limit it to the 50 meter or maybe 40 meter depending on the number of emitters discharge of each emitter. So this happens for the non-pressure compensating kind of the emitter. Okay, but but if you want the longer length of the lateral and if you want the more uniformity, okay, then the farmers go for, or we need to go for the pressure compensating emitter. In pressure compensating emitter, there is one arrangement actually in the emitter itself. There is one diaphragm kind of the arrangement. Because of that arrangement, if pressure is varied in certain range, the discharge will be same. Okay, if the rated discharge of the emitter is 4 liter per hour, and if you consider this lateral which is having 100 meter length, so if the pressure here is 10 meter and at the end if it is 6 meter, then within that pressure range you will get 4 liter per hour discharge only. Okay, so for that the certain diaphragm arrangement is made inside the PC dripper, of course, for which we have to pay extra for that. The cost of pressure compensating emitter is more, and at the same time we need the extra care because of that diaphragm we should have very effective filtration system. Otherwise, by chance if clay particle enters into the PC kind of the emitter, then diaphragm will be damaged and this PC emitter will no longer work as the PC kind of the thing. Okay, so in short, normal emitters which are available, or unless someone tells you that this is not PC emitter, those are NPC emitter, in which case the discharge varies as per pressure, and as discharge varies as per pressure and as pressure is more at the head and less at the tail, you will get the discharge difference, and if this discharge difference is much, then we have to limit the lateral length or we have to increase the lateral diameter in order to have the discharge variation within the acceptable range of 5 to 10% in order to get us the uniformity coefficient or emission uniformity more than 90 to 95%. Okay, but if we want to have the uniformity efficiency of 100%, or if you want to keep the length of the lateral more for the precise irrigation, then we can go for the pressure compensating emitter, in which even if the pressure varies in certain range, discharge is its characteristic as well. So for example, here there is a pressure x-axis, flow y-axis. So this is the NPC kind of the emitter. You see here the as pressure increases, flow increases. This is the green line, but if you see the red line, PC kind of the emitters. So for low pressure, of course, initially pressure has to be built up, so flow will increase, but then once pressure is built up, the flow is same even if the pressure is increased from this point to this point. Okay, so this is how this PC and NPC drippers will operate actually. The peculiar characteristics of NPC and PC drippers you can read on the slide. In case of NPC drippers, the flow rate varies with the pressure, possibility of non-uniform distribution of water for the long lateral, less number of the drippers per lateral if more uniformity is reduced. Okay, is required actually, sorry for that. Then PC drippers exhibit stable drip flow within a relatively large pressure range. I already told, ensures uniform water distribution in varying slopes of long lateral runs, also told this, and allows the use of more drippers in one line without compromising dripping flow rate stability. Okay, so in short, I will tell you that if you want to go for the precision irrigation management, then we need to go for the PC kind of the drippers, and in case of the general efficiency, if we want to get by the drip irrigation system, NPC drippers, they are okay, but for that system is to be designed properly. System is to be designed properly means the length of the lateral, diameter of the lateral, then length of the submain, diameter of the submain, and all those things. So those will come into your design things. Okay, next is again, so this is how the PC dripper will look like. So I have shown two kinds of the PC dripper. One is online PC dripper and another is inline PC drippers. In both the drippers, you see there is a diaphragm actually. So if pressure changes actually, this diaphragm will also move in such a way that if the pressure increases, then the opening of the emitter will reduce actually. Okay, so that by continuity equation you will get the same discharge. The same thing will happen in case of the PC kind of the emitters. Okay, the main function of the diaphragm is to control the opening with respect to pressure. Okay, so if pressure is less, then the opening will be more. Okay, so and if pressure is increased, then the diaphragm will regulate the opening such that the opening will be reduced proportionally, so that even for the low discharge and the high discharge in certain range you will get the same discharge. Sorry, so that even for the high pressure and low pressure in certain range, you will get the same discharge. Okay. Then point source and line source. In case of the point source, as you see, there is only one emitter here at certain interval, both the cases. In case of the line source, there is the discontinuous openings are there. So in case of the point source, you get the discrete drop of the water at certain interval over the length of the lateral, but whereas in case of the line source, you will get the continuous supply of the water along the length of the lateral. Okay. Then single exit and multi exit. Normally the emitters, they are of the single exit kind of the thing, but in case of the orchard plantation, where we need more number of emitters per tree, then there may be one main emitters which is connected to the lateral, and from one emitter then number of emitters will emerge, which we call as the spaghetti kind of the thing, and this number of emitters will be placed below the canopy in the root zone in such a way that entire root zone is wetted. So this is the multi-exit, but for row crops we need only single exit. Multi-exit we also need in polyhouses where we grow in pot. So instead of having 1 emitter per plot, then there are 2 rows of the plots, and for 2 rows of the plot there is 1 row of the lateral, and there is one main emitter as shown here, and this one emitter will take care of the four pots actually. So one main emitter is there, and from one main emitter 4 emitters will in fact emerge, and then each pot will be irrigated. So this is all regarding the multi. Dripper is the very important component. Of course, all its it will be more discussed in detail in the design lecture as well. But still, I couldn't resist myself in telling you certain design tips. Okay, I will again summarize. Dripper discharge. Okay, the dripper discharge should be such that it should be less than the infiltration capacity of the soil. That is, when the drop of the water falls over the soil surface, then it should immediately be infiltrated into the soil. It should not be ponded on the soil surface. That is, if you have more emitter discharge than the infiltration rate, then what will happen? Whatever the water has to be infiltrated, that will be infiltrated into the soil, but some of the water will build up on the soil surface. Now, when some of the water builds up on the soil surface, then because we adopt the drip irrigation method on the rolling topography, there may be certain slopes within the smaller area as well. As head builds up because of the ponding, the water will move from the tree rows or crop rows into the drier area, and that area will be wetted unnecessarily. So there will be weed infestation as well, and at the same time the water which is to be stored in the root zone, it won't be stored, it will be stored somewhere else actually, and we will consider that, okay, I have applied the water which is desired, which is in a desired quantity, but still I am not getting the proper growth. So this is because of this. And second thing is that even if the land is not slopy, and even if water will not flow from that row strip to the drier area, but still then water will build up, and as the water builds up, water will stand over there, and if it stands over there for a long time, the microclimate will be distorted, will be disturbed in that area, and because of which it will also invite some certain pests and diseases. So therefore, dripper discharge is very important. It should be as less as possible, but in case of the clay soil, it should be less than 2 liter per hour, and this is because to avoid the ponding. And I told you that what are the disadvantages of ponding and runoff. Runoff means it will go into the drier area which should not be irrigated. Ponding means it will disturb the microclimate of the region. Okay, whereas in case of the sandy soil, it should be a little higher, because more discharge is needed to ensure adequate lateral wetting of the soil, because naturally in case of the sandy soil, lateral wetting is less, and if we have the less discharge, it will be still less. So thumb rule I have shown: for heavy soil 2 lph, for light soil 4 lph, medium soil in between that, or maybe safely you can follow 2 lph. Okay, then pressure at the dripper. This I have told you that normally the rated pressure is 10 meter or 1 kg per centimeter square. So that is to be maintained there, and which is required. And if it is not there, then naturally you will get the less discharge. Say for example, instead of 10 meter, if it is 8 meter, so instead of 4 liter per hour discharge at what we call as the 10 meter, so you will get 3 liter per hour discharge, and you will consider that anyway you are getting 4 liter per hour, and accordingly you are applying water. But that is not the case actually. So pressure is to be maintained. For that, pressure gauges are there, and pump is to be operated accordingly. And the next thing which I just now described is the spacing between drippers on laterals, or number of drippers per tree, depends on primarily on the soil type. Okay, but before that we need to see how the water is sprayed into the root zone once the water drops through the emitters on the soil surface. So for that I will advise you to concentrate on the figure which is on the left hand side. So three kinds of the soils are shown there: heavy soil, medium soil, and light soil. Okay, and for each kind of the soil, okay, the bulb of the soil which is weighted is shown here. So you see that in case of the heavy soil, the dimensions of the bulb. So in case of the heavy soil, its diameter is more, or the lateral movement is more, but the vertical is less. And in case of the light soil, vertical is more and the lateral is less. Okay, so this means that when the soil is heavy, in heavy soil, when when the drop of water falls over the soil surface of the heavy soil, okay, then it spreads laterally more and vertically less. Okay, and in case of the light soil, it moves vertically more and spreads laterally less. So in case of the heavy soil, the wetted area which is formed is having more width compared to the light soil. In case of the light soil, the wetted soil zone or wetted root zone will have the less width but the more depth. And for the medium soil, as you see in the figure, it is in between heavy soil and light soil. So what is its significance actually? It has the significance on the spacing between emitters. Okay, so it's like that. Say for example, if you have heavy soil, then in case of heavy soil, if you have one emitter, then as that emitter will have more lateral spread, the next emitter has to be installed a bit away from the first emitter. But in case of the light soil, as the lateral spread is less, and if the first emitter is installed, the next emitter has to be installed closer to the first emitter compared to the heavy soil. So this means that in heavy soil we can have the more spacing between the emitters, whereas in case of the light soil there has to be less spacing between the emitters, and in case of the medium soil it is in between that. Okay, so in that way the spacing between dripper is affected because of the soil type. And this is very important parameters, because many people, many farmers, many practitioners are mistaken here. Okay, so what happens, the importance of the spacing between dripper is for the row crops actually. Okay, so in case of the row crops, that is the crops which we take in a row, such as the vegetable or say cereals, field crops, or flowers as well. So in this case, the emitter should be installed on the lateral in such a way that the entire strip of the row of the plant should be wetted. So as you see in the middle figure, okay, so here the entire strip is being wetted. Okay, so though you see the discrete wet patches, but this is on the surface, but in the root zone the entire strip is wetted actually. Okay, so the spacing between lateral spacing between emitters on the lateral should be such that the entire strip should be wetted. Then only all the plants in a row will get water properly. Okay, so then there is second row. So in second lateral also the spacing between the emitters on the lateral should be such that this entire strip should be wetted actually, and in between two steps there could be the dry patch as shown in the figure actually. Okay, so the drippers between the spacing between the drippers on the laterals for the row crops should be such that it should wet the entire strip actually. So that is important in case of the row crop. So in case of the row crop, it is not the number of emitters per plant or something like that, but it is the spacing between emitters on the lateral, and this spacing should be such that the entire strip should be weighted actually. And for that, in case of the heavy soil, the dripper system, the dripper spacing is more, and in case of the light soil, dripper spacing is less actually. Okay, because of the distribution of the water inside the root zone in case of the heavy soil and light soil, it differs actually. In heavy soil, lateral movement is more, and therefore spacing can be more. In case of the light soil, lateral movement is less, so spacing has to be less. So of course that for each kind of the soil we have to decide, but based on the experimentation conducted in the different parts of the world, for heavy soil we have prepared the thumb rule, in fact for all soil, regarding the drip spacing. For heavy soil, the dripper spacing can be 60 to 75 centimeter. For medium soil, the dripper spacing can be from 45 centimeter to 60 centimeter, and for light soil, the dripper spacing can be in the range of 30 to 45 centimeter actually. So this is just thumb rule, but I'm pretty sure that if you follow this thumb rule, there will be proper distribution of the moisture in the root zone as desired. That is, we have to wet the entire strip of the plant row actually. So that is possible. Okay. So what will happen if we keep the spacing between two emitters in light soil more than the desired one? Desired is 30 to 45 centimeter. So in this case, what will happen? As in case of the light soil, there is less lateral movement. If we are spacing more than 30 to 45 centimeter, then there will be dry patches in between two emitters, and as there is dry patches, entire row of the plant will not be wetted, and therefore plant will not get the many of the plants in a row will not get the desired water actually, and therefore plant growth will be hampered. Okay, but and vice versa, if we have less spacing in heavy soil than desired, what will happen? So in that case, as there is less spacing, there will be more drippers than desired, and the water will be stagnated, and the stagnated water will move into the dry patches, and again which is not advisable actually. Okay, so therefore this dripper spacing is very important, and this dripper spacing needs to be followed properly. So I have shown right hand side, this is the banana plantation wherein there is a single row of the lateral per row of the banana plant, and the emitter should be spaced in such a way that the entire strip of the banana row should be wetted, and for that the spacing between emitters should be as per the criteria which I have mentioned here, and I think this is very important. Now the spacing between emitters is for the row plantation, but if we have just seen for the row crop that the spacing between the emitters on the lateral is important, but if it is tree plantation, orchard plantation, whenever there are orchards and tree, then we don't go by the rule of wetting the entire strip of the row of the tree crop, but we have to wet the entire root zone of the plant or tree individually actually. Okay, and for that purpose, again the thumb rule is that whatever is the area of the canopy above the soil surface, the same area will be of the root zone actually, as shown in the figure. So root zone will be having almost the same spread area as that of the canopy actually. So we have to wet the entire active root zone, which is equivalent to the canopy area. Okay, and this canopy area in fact depends on the age of the tree as well. Okay, because as age of the tree go on increasing, the canopy area will also go on increasing, and therefore the area to be wetted per tree will also be more actually. Okay, but then what should be done actually? So in this case, then we have to have the number of drippers, okay, per tree in such a way that those drippers should be capable of wetting the entire root zone actually. Okay, and as we have already seen that in case of the heavy soil, again I have shown this figure at the left hand corner. In case of the heavy soil, okay, one dripper can irrigate more area because its lateral spread is more, whereas in light soil one dripper can irrigate the less area. So therefore, if the tree or orchard is in the heavy soil, then to wet the same root zone area, okay, we will need the less number of the emitters compared to the light soil. Okay, in case of the light soil, we will need the more number of emitters, because in case of the light soil, one emitter irrigates the lesser area, and in case of the medium soil, it is in between these. Okay, so again I repeat this. In case of the row crop, we have to see the spacing between the emitters so that the entire strip is to be wetted. In case of the tree or orchard plantation, we have to see the number of emitters that are required to irrigate the active root zone of the tree or the orchard plantation. Okay, and this depends on the root zone area. Root zone area depends on the canopy area, and also the age. And to irrigate and to find out the number of emitters, we have to consider the soil type, because in case of the soil type, in case of the heavy soil, one emitter can irrigate more area. In case of the light soil, one emitter can irrigate less area. So less number of the emitters will be required for heavy soil, more number of emitters will be required for the light soil. So as I have shown just below, the number of drippers per tree depends on now the area of the tree, that is the spacing between tree rows and spacing between trees in one row. Okay, because if area occupied by the tree is more, this is because the canopy is more. That's why area occupied by the tree is also more. Okay, then age of the tree and soil type as well. Okay, so I will give one just example how we differentiate in between this. Say for example, there are two kinds of the orchard plantation. Okay, so one is and fully grown. Say one is the pomegranate having spacing of 3 by 4.5 meter. Okay, and another is the citrus plantation having the spacing of 6 by 6 meter. And if we are going all those in the same kind of the soil, say medium soil, okay, then this pomegranate will need around 4 emitters, fully grown pomegranate plantation in medium soil, 4 emitter per tree. But if we but for the citrus plantation, it will be around 6 emitters per tree. So that is the difference actually. Okay, depending on the canopy area, because the canopy area in case of the citrus is more for the same age. And if we consider the soil type, suppose if we grow the pomegranate in light soil and in case of the heavy soil. Okay, in light soil, for the fully grown pomegranate plant, we will need the 6 emitters, but for heavy soil we will need only 4 emitters actually. Okay, because in heavy soil 1 emitter can wet more area compared to the light soil. So this is the difference actually. And actually age of the plant will also make the difference. Suppose if we consider say pomegranate plantation in medium soil or in say heavy soil. In case of the heavy soil, the pomegranate plantation in first year will need only 1 emitter. Okay, but whereas if we have the pomegranate plantation in light soil in first year, it will need the 2 emitters. If we go into the second year, maybe the pomegranate plantation on heavy soil will need 2 emitters, and whereas pomegranate plantation for light soil will need 3 emitters. Okay, and as we go further, the number of emitters will go on increasing actually till the entire canopy is stabilized. Okay, so this is how we have to consider the number of drippers per tree, and if there are more number of drippers to be installed per tree, I have shown one emitter arrangement as well along the ring. Okay, so just in order to summarize, the number of emitters, they are important, or spacing between emitters is also important. When we say that more number of emitters they are required in light soil, or spacing between the emitter has to be less in light soil, this doesn't mean that in light soil we have to apply more water. We have to apply the same water, okay, as per the crop water requirement, but the same water has to be distributed in the root zone, and for that we decide the number of emitters. Please remember that number of emitters doesn't have to do anything with the application of more or less water. We are applying same water but with less number of emitters in heavy soil and more number of emitters in light soil. In case of the light soil, if we use the less number of emitters than required, and if we are applying the desired quantity of water, it won't be applied, it will be deep percolated, and we'll assume that we are applying the same or desired quantity of the water. So this is the importance of the number of emitters or spacing between the emitters. Now let us move to the next pipe network. Of course, I elaborately explained the pipe network, but for the specific explanation purpose, I have carved out the pipe network figure only here. So if you see in this case, if you see there are number of subunits, if you count those subunits, those appears to be there is one left hand side and there is one right hand side. In left hand side there are 3 parts and each part is having 2 subunits, so 6 subunits and 6 subunits towards right hand side, so there are 12 subunits actually. So this is quite a huge field. You see there is main line actually, okay, then there is sub main line, then there is manifold, and then there are laterals. So this is a big field, and all kinds of the nomenclatured pipe exist in this field. Okay, the purpose of the main pipeline is to bring water from the water source up to the field, and so that in this figure it is doing. And actually in the field the submain pipeline takes water into the field, and main line provides water to the submain, and then submain provides water to the manifold, and then there are laterals on both the sides of the manifold, and manifold provides water to the lateral line. Okay, so in this case if the field is small, then maybe there is just main line, submain line and lateral, or sometimes we call as the main line, manifold and lateral. Okay, but when field is large, then there is main line, submain line, manifold and lateral as well. So this is the entire pipe network, and the length of all kinds of the pipes, that is lateral, submain, manifold, they are to be decided with proper design, and also the diameter of all kinds of the pipe, that is lateral, submain, manifold and main line, has to be designed hydraulically properly, and this will be of course covered in the design class. But this is all about the pipe network. Then the first pipe in the pipe network is the lateral pipe. Okay, lateral pipe is made from the LDP, that is the low density polyethylene pipe. I have shown this figure as well. Now the characteristics of the low density polyethylene pipe is that even if it is exposed to the sun, it doesn't brittle, and its life is around 6 to 7 years. And in market these laterals, they are available in the outer diameter of 12 millimeter, 16 millimeter, 20 millimeter, or if you have large field, you can also get the specially designed diameter lateral line. Okay, but the length, now length is to be decided actually, or designed. Okay, lateral length is to be decided in such a way that we get 90 to 95% the emission uniformity. Okay, and then regarding laterals, there are certain other components as well, smaller components, that is takeoff grommet, elbow, jointer, end cap, lateral caulk, etc. I have shown this on the right hand side bottom figure actually. Okay, then in that case, the first you see the elbow. So elbow is also required. A special elbow is required when we have what we call as in one season the crop with this less lateral spacing, and in another season if we have the crop with more lateral spacing, then just to adjust the position of the lateral we need elbow. Okay, then T's are required if we want to further divide the subunit actually. Then the third is lateral caulk. Suppose if we want to control the flow into each of the laterals, which may not be necessary in the field, but if we have to control, then the lateral caulks are there, or if we want to irrigate the marginal land, then maybe lateral caulks are required. Then the fourth is the connectors actually. Okay, so if we want to connect the two laterals, then these connectors or jointers are there. Then next is what we call as the end cap is there, and below that the takeoffs are there. Takeoffs are required for connecting lateral to the submain. Okay, so in short, this is all about the laterals. It is made from the LDP material, having 6 to 7 years life, even if it is exposed to the sun, no problem, available in different diameters. Length is to be designed, and there are different types of the connectors and jointers, elbow, in order to install the laterals in a subunit field proper. In case of the lateral, the important thing is the arrangement of the lateral. This is also important. Normally, in row crop, maybe one lateral is required per row of the plant, and this is for the widely spaced, such as banana and grapes. These are the widely spaced row crops. So as shown here, one lateral is required per row of the crop. Okay, but if the plant rows are closer to each other, so just like vegetables and other things, we may consider the one lateral for 2 rows of the crop, as I'm going to show you in the next slide. This vegetable plantation or less space plantation, then instead of having one what we call as one row, one lateral per row of the plantation, you can bring 2 rows of the plants near, and you can have one lateral per 2 rows of the crops, actually, as I have shown here for the different kinds of the crops. Cabbage is there, cotton is there, and many other crops are there, actually. So this will save us the lateral cost. Okay, so this is also called as the paired row planting. Earlier I have shown for banana, so it was only one lateral per row of the banana plantation, and here this is the one lateral for 2 rows of the vegetable crop, actually. So this is called as the pair row plantation. And for some very close space crops such as onion and garlic, we can have one lateral for 4 rows of the crops as well. Okay, so depending on the crop geometry, we have to also change the lateral geometry in order to ensure that we need a less number of the laterals, and at the same time we apply water efficiently. Okay, this is for the orchard. In case of the orchard, it is a bit different, actually. In orchard, we may need 2 lateral per row of the tree, actually, because in case of the lateral, in case of the orchard, as plant grows or tree grows, then we need more number of the emitters per tree. So it can go as high as 15 emitters as well. Say for example, if there is a light soil, and if we have orange plantation at 6 by 6 meter, then we may need 12 to 15 emitters per tree, actually. Okay, for coconut it will be still more. Okay, so under such cases, it is not like the row plantation, wherein depending on the soil type, we can have the spacing between emitter less or more. Okay, in order to just wet the entire strip of the row. But here in this case, if the emitters are more, then we have to arrange these emitters around the tree so that the entire root zone is wetted uniformly. Okay, so if you see from the left side, one by one, the first figure is shown as there is only one lateral per row of the tree crop. So this is sufficient when 3 to 4 emitters they are required per tree, actually, as shown here. Okay, but when more number of emitters are required per tree, then we have to have 2 laterals per row of the tree, actually. So here it is shown. This is the tree rows, and there are 2 rows, actually. So this is double laterals, actually, as against the pair row planting in vegetable plantation. Okay, alternative to double row is that we can have the multi-exit kind of the emitters here. That is, for at each tree there will be one emitter. There will be only one lateral row per tree, and near each tree there will be one emitter, and from one emitter there will be number of emitters, so which we call as the spaghetti or multi-exit kind of the emitters, and these emitters can be placed over the soil or the root zone, actually, so as to wet the entire root zone. Or we can have these laterals. Now you see the right side figure. We can have the lateral which are wounded around the tree, actually, like this. Okay, so we can make such kind of the arrangement as well. Or we may have, there is one lateral, and to this one lateral there is again small piece of the lateral attached, which is wounded over the tree, and on this small piece there are the emitters, actually. So these are the different lateral arrangement. So here I have shown this pomegranate plantation. Of course, this is with mulch. You see there is only one lateral row per tree, but whereas on right hand side there are two lateral rows per row of the tree. Okay, then we can have the ring around the tree as well, like this. Okay, so this is the picture of the ring, and this is actual installation. Okay, and on this ring we can install the laterals drippers actually. The next manifold, submain and main. I have already explained you what is the position of manifold, submain and main. So here it is again shown. But normally manifold, submain and main, they are of the PVC material or HDPE material. Only one caution is to be taken: when we use the PVC material, then manifold needs to be buried into the soil. If it is open and if it is exposed to the sun for a long time, there is quite possibility that those will be brittle, and those will develop the cracks even after 1 year itself. So when you use PVC kind of the manifold, submain and main, take care that those are buried into the soil. But if you use HDPE, no problem. So you can install those on the soil surface, no problem. Okay, length and diameter of the manifold, submain and main has to be designed as per the flow and pressure requirement. Okay. Now let us move to the next, filter. As I already told that even if we use the distilled water, we need to have primary filter in the form of screen filter or disc filter. So that is what I have written here. Every irrigation system needs to have a filter. No matter how clean your water is, a filter is cheap insurance to guard against debris entering your irrigation system. Even small particle in the water can cause drip emitters to become clogged actually. So this is the importance of filter. Filter is considered as the heart of the micro irrigation system because of this. So if you don't have filter, forget the smooth and efficient operation of the micro irrigation system. Many times farmers, what they do, they install the filters, but they bypass the filters, and then if they bypass the filters, then naturally the drippers will be clogged, and once drippers are clogged, they are huge in numbers and it is very difficult to locate them, and there will be highly ununiform distribution of the water. So filter is the heart of the drip irrigation system. There are different types of the filters: screen filter, disc filter, sand or media filters, and hydrocyclone filter. Out of which screen filters and disc filters, they are considered as the primary filters, and one of these filters must be used even if we are using the distilled water for the irrigation actually. It is not necessary that both should be used, one of these, because they have the same function actually, only its filter element is different. And next is the sand and media filter. Sand and media filters, they are to be used, as I already told, when there is the organic material, certain kind of the debris, leaves, and similar other kind of the material, those normally exist in the open well, open ponds. So then there is a necessity of sand or media filter. And hydrocyclone filters, they are required whenever we take the water from the source where there is sand, such as lift irrigation, river lift irrigation, or when we take the water from the tube well. Now let us by one. Screen filters, actually I have shown here one typical photograph of the screen filter along with pressure gauge. Pressure gauge is very important. It will be covered in the maintenance and operation part of the micro irrigation system. A screen filter uses a rigid or flexible screen to separate fine particles out of water for irrigation actually. Okay, I will show this screen in next slide. Okay, so in fact the screen filter or disc filter for that matter has two main components. One is the filter casing, which you can see now, and inside the filter casing there is filter element. So filter element in case of the screen filter is screen itself. Okay, so screen filter uses a rigid or flexible screen to separate fine particles out of water for irrigation. These are generally not recommended for filtering out organic matter such as algae, since these types of the contaminants can be extruded into spaghetti-like strings through the filter if enough pressure drop occurs across the filter surface. That is, if you have the water with impurities such as algae, and if you try to use the screen filter directly instead of using the sand filter, then this screen filter will be blocked immediately actually, because these algae cannot be separated, but this will enter into the filtering element and this will block the filtering element. Okay, so we have experienced that if we use the algae water or water with organic impurities, the screen filter is blocked even in one day itself actually, so it needs to be taken. Here I have shown you how the flow takes place in screen filter. So this is one typical figure. You see there is one inlet from here, and water is entering here. Then there is the screen element. Then as water entered into the filter through this filter casing, screen element will retard or keep away the impurities on the screen itself, and impurity free water will come into the inside, and then it will go into our main line through this outlet actually. Okay, so there is one handle to remove the filter element from the filter, so that we can clean these. Okay, and of course these are the important components of the screen filter itself: filter elements, screen, walls, pressure gauge. Okay, and typical screen material include nylon, polypropylene, stainless steel, and polyester actually. These are the materials for the screen element. And screen filters are cleaned by flushing them with a stream of water or removing the screen and cleaning it by hand. In fact, for this it is better to open the screen filter, remove the filtering element, and then wash this filtering element against the high pressure stream of water, or just clean by hand actually. And in the downmost I have shown the filter element. Here this is the screen filter element and casing as well. The next is the disc filter. In fact, disc filter is also primary filter and it is alternative to the screen filter. So disc filters, they are similar to screen filter except that the filter element is different. Okay, that filter element is in the form of cartridge made out of a number of discs stacked on top of each other like a pile of poker chips actually. Okay, you know the poker chips. Okay, so those are mounted like stacks of the disc with each other, and water passes through the small grooves in between and impurities are trapped behind it. What happens here, you see the filter element with number of the discs actually. Okay, then each disc having the small grooves actually. So when they are stacked against each other tightly, then the small path is developed through which only water can pass actually, and the impurities can be retained over the disc. Okay, so this is the main working principle of the disc filter. And if you want to clean the disc filter, you can just remove the screen, dismantle the screen, and wash in bucket. It is quite easy. Next is sand filter or media filter. Sand filter or media filter is must whenever there is algae or organic impurities such as leaves and debris into the water. Okay, so this kind of filter is usually required in peculiar cases when the water source is open well, ponds, rivers, or canals with algae or organic matters. The sand or media filters perform the filtration of water through a thick layer of graded particle as shown in adjoining figure. These particles can be sand, gravel, or other granular materials. The filtration rate of course depends on the effective size of the bedding and the water velocity through the filter. Water enters through the filter inlet and percolates through the filter bed as shown in figure. Suspended matter when comes in contact with media particles are retained in media itself. So here you see that there is inlet at the top, so water from the main line will enter into this tank. Okay, basically sand filter is nothing but a tank which is having the bed of sand of the particular size, and below the bed of the sand there are the nozzles like this. These are the small filters actually. So what happens when water comes inside through inlet, this water through the debris and impurities will pass through this sand bed. While water with the impurities is being passed through the sand bed, the impurities they are retained in the sand bed or above the sand bed, and impurity free water will be screened and will pass into the outlet actually. Okay, so in this way this filtration mechanism happens. Here I have shown you some examples of the sand filter. They are horizontal type, vertical type, and I have shown you one cross section as well. You can see in this cross section, this is the tank, then the nozzles which acts as the filter, they are shown. The sand will be filled. Okay, so this is the inlet. Water will come from the inlet and will pass through. The pipe is perforated again just to have the extra safeguard. Then the water will pass through this sand bed, and impurity free water will come to this nozzle, and then these are in fact the screens actually, and this will then come into the outlet. Sand filters, if there are a lot of debris, it needs the regular cleaning, and for that back flushing is done actually. In the first figure which I have already shown, this is the filtering process actually. In filtering process, you see water is coming from the inlet and it is moving from the outlet. In back flushing exactly we do the reverse actually. In case of the back flushing, we allow water to pass through the outlet actually, as you see. Okay, pass through the outlet. So we allow water to pass to the outlet, and then we discharge water from the inlet. So in this process, what happens, as we are passing the water with high pressure, whatever the impurities they are retained into the sand bed, those impurities will move along with the water through the inlet, and there is one cock and which will be taken out of the system. So this is the filtering process, and this is the back washing or back flushing process. Okay, so the position of the walls for the back flushing is shown here. Say in first case it is the filtering operation, and you see this is the inflow. There are 4 walls actually. Sand filters needs 4 walls actually. 2 walls for the inlet, 2 walls for the outlet. Okay, so if you consider this as the inlet top and bottom as the outlet, then you see in case of the filtering process, the first wall is closed here, and so that water will go from this pipeline into the sand tank actually, and this wall needs to be closed for this purpose, and then water will be filtered, and this water, anyway this wall is open, so water will go into the outlet actually. In case of the back flushing, the valves which were open during the filtering process needs to be closed. Okay, so that in case of back flushing, the water will now go instead of moving through the inlet, so water will move from the outlet actually, which is at the bottom, and then it will come into the inlet, and as this wall is open, the water with the impurities will be taken out actually. So this is the back process. Then the hydrocyclone filters. Hydrocyclone filters are used in irrigation system to remove sand and silt particles from irrigation water. This is made out of mild steel construction, and it is hydrodynamically designed to create maximum centrifugal action to separate particles heavier than water. It removes efficiently sand and silt. Now in this case, as you see, this is the typical shape of this hydrocyclone filter. Now the principle of the what we call as the centrifugal action is used here. In this case, as you see here, this is the inlet. Water with high pressure will enter, and as water enters, then the heavier particles, okay, so heavier particles will strike the wall of the filter element, and then it will be stored in the bottom tank, and the impurity free water will go through the outlet like this. Okay, so it in fact uses the centrifugal action, that is the water with the impurities is made to rotate at high speed, so that the heavier particles will be separated as those strikes the wall of the hydrocyclone filter, and then incidentally those will be collected at the bottom of the hydrocyclone filter, and water with the impurity free will be taken into the outlet and eventually into. Okay, so this is one typical figure how the process happens actually. Now you see this is the inlet. In this case, pressurized mud enters tangentially here. So through this inlet, the water will, the impurities, that is sand, will enter. Then once this is there, so this is the chamber actually of the typical shape to create the centrifugal action. Then rapid rotation develops the centrifugal force in the cyclone actually, because water is moving with pressure. So because of this, there will be rapid rotation at it, and it develops the centrifugal force. So because of this,
liquid moves inwards and upward as a spirally vortex like this. The liquid is moving inward, that is at the center, and also upward, that is towards the outlet actually. And solids are driven to the wall and are moved downwards in a accelerating spiral actually. You see, so solids are moving downwards and also driven to the wall actually. Okay, and then it is collected into this tank, and which we can we can remove as well. So basically, in case of the hydrocyclone filter, the water with impurities enter, made to rotate at rapid speeds in order to create the centrifugal force, and after that the liquid will move inward and upward, so that it will be taken out as pure water, and solids will move downward and along and towards the wall. Okay, so in this way this happens actually. So this is what I have shown you, the picture of the hydrocyclone filter.
Fertigation unit. Fertigation unit is the last important component of the micro irrigation system. Now, fertigation, all of us know that fertigation is a process in which water soluble fertilizer or liquid fertilizer is distributed along with water in drip irrigation system. That is, whenever we apply the water and nutrients together through drip irrigation system, that is, with every drop of water whenever we applied fertilizer, then we call this as the fertigation. And to make this possible, we need the unit which is called as the fertigation unit. In case of water soluble fertilizers, they are first dissolved, diluted and distributed along with water in irrigation system actually. So if water soluble fertilizer is there, so naturally we have to dissolve, dilute and then distribute. If liquid fertilizer is there, then it is dissolved and already, then we have to dilute and distribute actually. Okay, there are many fertigation devices, okay, which are some locally developed as well. Okay, but the important and popular, they are pressure tank, venturi and piston pump. Okay, here I have described the fertigation tank. Okay, now you can see the different this is in fact the flow diagram of the fertigation tank. Now what happens in case of the fertigation tank is that this is the cylindrical and epoxy coated pressurized metal tank, and this is resistance to the system's pressure and connected as a bypass to the supply pipe of the head control or control head actually. It operates by differential pressure created by a partially closed valve placed on the pipeline between the inlet and the outlet of the tank. Part of the flow is diverted to the tank entering at the bottom. It mixes with the fertilizer solutions and the dilution is ejected into the system. The dilution ratio and the rate of injections are not constant. The concentration of the fertilizer is high at the beginning and very low at the end of the operation. However, this particular fertigation unit is still in service on very small scale in some countries, because it is low cost and also easy to manufacture. Okay, so one of the greatest drawback of the fertilizer tank is that the fertilizer concentration goes and reducing as the irrigation process, but nevertheless this is the cheap arrangement and is being used at many places. These are the examples of the fertigation tank, how it looks like, and some fancy photos as well. And the venturi, which is most predominantly used actually. Okay, so you see it is very easy. In this case also concentration is problem. Okay, but as you see, this venturi is based on the principle of the venturi tube. In this case, a pressure difference is needed between the inlet and the outlet of the injector, and therefore it is installed on the bypass arrangement placed on the open container with the fertilizer solution. The rate of the injection is very sensitive to pressure variation, and small pressure regulators are sometimes needed to make the constant ejection actually. Okay, so in this case you see the figure, there is a water inlet and the venturi is installed across the pipe. Okay,
like this, and this is the bypass arrangement. And when fertilizer is to be injected, this wall is closed, okay, or it is partially closed actually, so that some of the water will be bypassed through the venturi. In venturi there is one contraction, so whatever the here pressure head is there, that will be converted into velocity head. So there is pressure difference between now this inlet and this particular point, and because of this pressure difference, the fertilizer solution which is kept in bucket or container here will be sucked into this pipe, and this will be mixed with the water and towards the outlet actually. So this is the one venturi unit which is shown here. The venturi is commonly used nowadays by the farmers, though there are problems associated with the uniform and constant ejection or injection rate actually. So again, I would like to explain this as you see this is the main pipeline, and across the main pipeline this venturi is fitted as the bypass arrangement, okay, and there is a wall actually. When fertilizer is to be provided, this wall is partly closed, okay, so that some of the water will be bypassed through the venturi here. And as you see, venturi has the contraction, so because of which here the pressure head is converted into velocity head, and therefore there is pressure drop in the system. And because of this pressure drop, the water with the fertilizer which is kept in the container will be sucked into the system here, and then it will be applied through the drip irrigation system. Okay, this is also one such venturi unit which is available in the market, and it is easy to use as well. Okay, what we have seen is three kinds of the fertigation unit. One is fertigation tank, which is also known as the pressure tank, venturi, and this injector pump. First, fertilizer tank and venturi, they give non-uniform distribution of the fertilizer, but they are less expensive. Injector pump, though it gives the uniform concentration of the fertilizer into the system, but they are expensive as well. Other components, there are pumps, valves, pressure gauge, and bypass assemblies. These are the different other components. The pumps can be centrifugal pumps, submersible pumps. The important design parameter of the pump is its discharge and its head actually. So in the design training module, you will learn how to design the system, and what should be the discharge of the pump, and at the same time what should be the head of the pump, and accordingly you need to procure the pump from the market. Now in short, we'll see the different versions of the subsurface drip irrigation system. Okay, different versions of the micro irrigation system. So as we have seen, drip irrigation system first, then subsurface drip irrigation, micro sprinkler, and bubbler we are going to see. Okay, but the components more or less they are same. Only there is a difference in the component which emits water actually. We have seen the surface drip. Just like if you see the first picture, surface drip lateral is placed on the soil surface, and in case of the subsurface drip it is same, but the lateral is placed some 10 to 15 centimeter below the soil surface. Okay, so because of which it has been observed that there is additional saving up to 10% because the evaporation rate is reduced. Then micro sprinkler. Basically micro sprinkler system, they are used as the under T sprinkler irrigation system. That is in case of the orchard plantation in light soil, we need many numbers of the drippers per tree. Okay, but however, instead of that, if we use one micro sprinkler, it will suffice the need of many emitters as well. So micro sprinkler is developed as the under tree kind of the sprinkler. Only instead of emitter there is micro sprinkler. It will also again throw the water in the form of rainfall, but at the lower height as shown in the figure. Okay? And when we use for the under tree, there is no criteria of overlapping and any other things. So depending on the canopy area to be irrigated, we have to choose the micro sprinkler and also maintain the pressure.
But these micro sprinklers, they are further used for irrigating the close growing crops such as wheat, onion and garlic as shown in this particular figure. But when we use this for irrigating the close growing crop, then of course the design parameters of the spacing between two micro sprinklers will come into the picture. Bubbler irrigation. So bubbler irrigation, in this case, in fact, we bring water through the network of the pipe up to the tree, and tree is having one basin as shown in the figure, and then water at the desired pressure will be applied there through the device called as the bubbler, and all other components they remain.
We have seen the micro irrigation system, and major micro irrigation system is the drip irrigation system. So we have seen the drip irrigation system in details along with its advantages, disadvantages, components, and followed by we have seen briefly the other types of the micro irrigation system, that is micro sprinkler irrigation system, then subsurface drip irrigation system, and bubbler irrigation system. Now this is the different kind of the irrigation system which we call as the subsurface irrigation system. Remember that this is not the part of the micro irrigation system, but in the beginning we have seen there are four kinds of the irrigation system. One is surface irrigation system, another is subsurface irrigation system, third is sprinkler, and fourth is the micro irrigation system. So this is that subsurface irrigation system, and this is the one specific version of the subsurface irrigation system which is practiced in some part of the world actually, and specifically on the loamy side. But before that we should understand what is the principle of the subsurface irrigation. In subsurface irrigation, it is entirely, its philosophy is different than other three irrigation methods, that is surface, sprinkler, and drip micro sprinkler micro irrigation system. In all these three irrigation system, that is surface irrigation system, then sprinkler irrigation system, and the micro irrigation system, water is applied to the crop as per its need actually. Okay, but in subsurface irrigation system we don't apply water, we maintain the water, and plant root takes water from the soil root zone as per the need. So this is the basic difference between the subsurface irrigation system and other irrigation methods. In case of subsurface irrigation system, historically what is done for this purpose, certain water level is maintained below the root zone of the crop, okay, with the help of drains, okay, and as this water level is maintained, then below the root zone of the crop, the water from the capillary will rise into the root zone of the crop, and water level is maintained near about at the field capacity in the root zone of the crop. Okay, so whenever crop needs, then the roots will take water from the root zone, because already there is water by means of the capillary in the root zone, and as the water is depleted from the root zone as a result of the uptake of the water by the plant through its root, okay, so that water will be replaced by a capillary water which is coming from the water table which is maintained beneath the root zone of the crop. So this is basically the principle of the subsurface irrigation method. But this is specifically one type of the subsurface irrigation method which we also call as the porous pipe subsurface irrigation method. So in this case, instead of maintaining the water table with the help of the trenches beneath the root zone, here what is done, just below the root zone, or maybe in the latter 2/3 part of the root zone, porous pipe is laid into the field actually, just like we lay the subsurface drip irrigation. Subsurface drip irrigation laterals, they are a bit shallower actually, 10 to 15 centimeter below the soil surface, but this is this is a bit deeper actually, 25 to 30 centimeter below the soil surface. The porous pipes, they are installed actually. Remember that these are not the inline drip or subsurface drip, but these are the porous pipes actually. These porous pipes, they are installed as I have shown you in the second figure, and how this porous pipe looks like, those also I have shown in a bottom figures actually, bottom photographs. Okay, so these porous pipe, those are installed just like we install the drip laterals into the field. So these porous pipes, they are connected to the main sub-main pipeline, and sub-main is connected to the main, and main is connected to the overhead water tank in this case. Remember that this is the overhead water tank. Okay, the purpose is that in subsurface irrigation method, as per its philosophy, water table or water is to be maintained beneath the soil surface all the time actually. Okay, So in this porous pipe subsurface irrigation as well, water is to be maintained in the porous pipe all the time. Okay, and when plant root takes water, okay, from the soil root zone, because what happens in case of the porous pipe, it is the porous pipe, and inside the pipe water is maintained with the full potential, and in the root zone initially the water is not at the full potential actually. So therefore water will sift from the porous pipe into the root zone. Okay, and that water will be there, and as plant takes water from the root zone, okay, so water will be depleted from the root zone, and this depleted water will be replenished by the water from the porous pipe, and in porous pipe water will come from the overhead water tank. So therefore in case of the porous pipe, the water is to be maintained into the pipe all the time, so that whenever plant root needs the water, they can take from the soil root zone, and depleted water will be replenished by the water into the porous pipe through the porous wall actually. Okay, so this is the specialized type of the subsurface irrigation method, but though it is not categorized as micro irrigation method, but it also needs the less discharge, micro discharge, as in case of the micro irrigation method. So I thought let us spend few minutes to describe this subsurface irrigation as well.
Okay, this is one example of the low head drip irrigation system. This is just using, instead of dripper we can use micro tube. It can operate on the head. Okay, so with this I would like to remain here. Thank you very much for your patient listening. Of course, if there are any questions, you can pass those questions on. And again, I would like to summarize here that in this particular training lecture, we have seen in general what is irrigation scheduling, then some basic principles of surface irrigation method, sprinkler irrigation method, and micro irrigation system in order to differentiate amongst these different methods. Then layout of the micro irrigation system, then different components of the micro irrigation system, then different types of the micro irrigation system, and we have also learned the important characteristics of the important micro irrigation system actually. So with this I would like to remain. Thank you very much.